All right, everyone. Welcome to day 2 of ETH Seoul. First up, we have Ilya, the founder of Near Protocol. He'll be doing a talk on building composable decentralized front ends.
Hello, everyone. Thanks for coming this early on Saturday after all the partying that some of you did. So, kind of historically, Near started as a layer 1. We kind of originally really were trying to ourselves use blockchain for solving our own problem, and we kind of struggled with finding a platform and infrastructure that really would enable us to kind of build products that are mass user, that are easy to implement and maintain, and that actually can scale with the user base. And so that's how Near started, is how can we make a simple to use and build secure and scalable blockchain? And so this started in 2018 and kind of launched in 2020. And since then, kind of as the ecosystem grew, we continued providing more developer tools and platform to startups and companies that want to build in Web3. And so a lot of the focus in 2022 has been on building out kind of a rich set of tools and infrastructure above the blockchain. But as we kind of worked with startups and companies, we realized that even though, like for people who are building on Near, a lot of the things are already solved and they're actually like able to build really quickly, the challenge has been acquiring users, retaining them, making sure they're engaged. And as we kind of were figuring out how to start solving that problem, we have formulated this idea of what we call blockchain operating system. And so we just released it about a month ago, and kind of this is our next step toward the billion users goal we have to bring to Web3. So what is blockchain operating system? Really, it's an idea of how do we have a common layer for browsing and discovering open web experiences, Web3 experiences, and it's compatible with any blockchain, right? Why is this important? Because there are a set of problems that Web3 has that, if you're in Web3, you're familiar with, which is it's really hard to have discoverability. It's really hard to have kind of re-engagement of users, but also the multi-chain itself actually adds a lot of extra development costs, and it leads to a fragmentation, right? You have now user bases that are fragmented between different chains, and then within them have like additional fragmentation. So it's really hard to engage all of these users and really grow your user base. Now, Web 2 has a lot of challenges as well, right? So obviously the lack of data ownership and privacy, that's kind of why we working on Web 3 in the first place. But also, even with kind of standard applications, we have lots of censorship that Apple and Google are kind of in a way forced to do, and part of their business model is to do, as well as there is a lack of user retention kind of in a broader space. And there's a set of common challenges, like onboarding, that, if you're building a startup, even in Web 2, you probably have a massive team to just focus on onboarding users. And similar in Web 3, there's been a huge struggle to get users to onboard and start using applications. The distribution, right, getting in front of users, starting them to experience your application. Complexity to build for especially multiple platforms, right? If you're building for iOS, Android, web, you need to build 3 different apps usually, and you need to have 3 different teams. And so all of this, right, set of challenges that we're trying to kind of coalesce under this new paradigm of blockchain operating system. How does this work, right? So it's a kind of, blockchain operating system is not one thing. Similarly to regular operating systems, which are a kind of a platform that allows developers to build on, not need to think about the underlying hardware, kind of abstracting that out, and at the same time giving the distribution channel to the application developers that they don't need to really focus on, right? So if we're talking about iOS, for example, right, they have an app store, and so developers can install, can build the application, and users can install, and so the distribution is handled by Apple in a way. And developers don't need to think about the low-level details of the CPU, right, and how they're changing from version to version. That's handled by iOS as well. So similar idea here, but applied to a blockchain kind of broader software services. So on a bottom layer, we have blockchains, right, and smart contracts. And, obviously Near as, Aurora and Octopus and other kind of various layers on top of Near. Similarly, Ethereum with layer 2s there, and also other blockchains. Now, the kind of idea of abstracting out all of this complexity really comes from so-called middleware, right? So we call it data platform, and this is where all the data aggregation, data kind of processing, as well as streaming, notification, search, and various other services go, right? They really try to kind of build a layer of layers that now you as a developer can just use and not think about the specific details of specific layer 1 or layer 2 that you use for handling the identities, the smart contract, the value. Important parts also here are really abstracting out the complexity of gas, submitting transactions, all of that details that usually you as a developer need to handle, and really giving you kind of very high-level instruments to do that. Now, the new layer we added, right, we call discovery. And discovery is this idea that we want to do what smart contracts did to kind of web services. We want to do that to front ends, right? We want to make them autonomous, composable. We want to make them, always accessible and kind of cryptographically secure. And so generally in front ends, if you kind of right now look in Web3, they run by a centralized server, they're maintained by a single company, they are kind of susceptible to various hacking risks, DNS injections, all kinds of things. And at the end, they're highly non-composable and highly kind of hard to maintain as well. And if we talk to various teams, especially in DeFi, right, they have a lot of challenges as well with kind of the fragility of this, as well as lack of other applications being able to hook into their smart contracts because they cannot just take and reuse their front-end code that continues to evolve, right? They need to kind of completely rebuild and maintain, let's say if you're a portfolio app that wants to introduce swap, you need to maintain your own pretty much application for that. So the idea of discovery is really to solve all that and then package it up in so-called gateways. So gateways is really where all of this comes together. The blockchains, the middleware, and the discovery, the front ends, really come together and surface it to the user. And it works with different wallets. It can be embedded into the wallet itself, and can be even browser or local app that actually runs all this locally. And I'll kind of show some of the examples. So at the core, what we're trying to do is actually turn around this issue right now, that if you're building Web3 application, you actually are trading off on distribution, right? You most probably have trouble with launching application in App Store. You have lack of kind of discovery of your application across various things. You can put it on like App Store or on DappRadar, on like a few other places, but it's really hard for people to find it. And you are kind of having this fragmented user base. So like if you build on X chain, right, then the users of all other chains like have really trouble onboarding and using it. And so instead, we want to leverage decentralization and be the driver of distribution, right? So the more kind of different places, so-called install blockchain operating system in them, the more we have users who are actually accessing the common set of applications and services kind of in this space. And so because of this, like all of this is censorship resistant, anti-fragile, it works with all the chains, and it's really allows to discover applications and start using them without needing to kind of re-onboard, like create new wallets, figure out like if this application is secure, has it been launched by some malicious actor. So all of this really what we're trying to solve. So what is it for developers, right? We're at the hackathon here. Like, why do I care? Well, so important part actually is this is a faster developer environment. What it means is, like, if you're a developer and you want to build an application, and I'm not saying Web3, I'm saying generally any application, what we're aiming for here is that this is a faster developer environment than any other alternative, right? Important parts is because you have this existing kind of base of applications and so-called components for the front ends, as well as smart contracts for the back end, you can actually really quickly compose together new experiences. You don't need to kind of rebuild everything. You don't need to rebuild the scaffolding to kind of set up all the wallet. Like I remember the first time I was trying to build on Ethereum, like just hooking up wallet and kind of getting all that started, like took a while, right? So all of this is solved. Again, same on Web 2, right? Even with Auth0 and kind of other services, all of that takes time. Here, you don't need to kind of handle any of that. You have all the kind of, we have over 4,000 components at this point, from very common ones, right, to some esoteric ones. And you get right away usage, right? Because you can post it on the social feed and people can click on it and start using it right away. They don't need to relog in. They don't need to kind of rediscover and figure out if like they trust, this website with their identity, etc. So all of this kind of really gives you faster developer environment and you can kind of quicker go to the user. For kind of enterprises, companies, what this allows to do is if you already have existing application or a property, right, website, you can actually embed all this directly into this app, right? So because kind of all of this, the gateway idea is kind of very easily composed into existing websites with just a few lines of JavaScript, you can actually embed the whole kind of rich Web3 experience without really needing to kind of design all that from scratch. And it allows you to really easy onboard new users, like your users into Web3, right? They will not even see that they have, crypto accounts initially. And it allows to start surfacing lots of different experiences. So, if you, for example, a luxury brand, you can, surface a secondary market for your items, and like people will just use that as if it was under your brand inside your website, but actually they're using an NFT marketplace underneath that they're using with their crypto account, but they don't see that and kind of start interacting with that. It is way easier to build and maintain, right? Like again, all of the components and the services, right, are provided by blockchain operating system, and you're really just filling in your kind of design and your kind of minimal logic that you want to hook in with your specific business. And finally, you can access any of the existing user bases and existing kind of economy that blockchain has. Finally, for individuals, the important part here, right, at the end we're trying to build Web3 kind of user-focused internet, is that you now have kind of this ability to, wherever you go, you always own your data, you bring your experience to any of these places, right? And again, like if we go back to this luxury brand, for example, they embedded it. If you already have an account somewhere else, you can just log in with that account and start already using even this luxury brand marketplace, but with all of the data and assets that you have. And so that's really kind of powerful. And like if you have social features, for example, your profile comes with that. So instead of this idea that like, Facebook owns your data, Twitter owns your data, and they kind of have it in their own places, now the data is owned by you, and wherever you go, whichever application you use, like the kind of your data, your social graph, your assets are coming with you. The discovery of applications, kind of the interactions with them, the kind of like the security that that this application will not try to rug pull you, all of that comes in as well with this platform. And finally, this kind of universal social interactions as well is extremely powerful. We call this community commerce, and really kind of allowing people to connect, collaborate, manage assets, create kind of commercial relationship, create collectives that are together creating value. All of this is kind of really coming together in this. Now, the most important thing, all of this is live. Obviously, there's still a lot of work to do, but we have all this running, and I'll kind of show you a basic demo, like kind of walk you through some of the things we have. But before that, one of the most important things we've been focusing on is how to improve the onboarding. We've been trying to do this from kind of day one. We've tried a bunch of things. And one kind of the thing we launched last month, we call Fast Auth. So this allows to use on-chip cryptography that exists on every device now to really with Face ID or fingerprint or PIN to create kind of the cryptography for the blockchain account without user needing to go through seed phrases and all this complexity. And then there's multi-party computation, so the kind of way to do setup email recovery, and then you can also have other ways to recover your accounts over time. And so all of this really allows to have like almost, it takes about 5 seconds. You don't see any crypto kind of jargon or any crypto like 0x, ... things. You don't need to set up seed phrases and save it. And usually people just screenshot it into their photos. Like none of that is just a kind of faster than regular because you don't have password here. You just enter the email. You can get an account ID and confirm the email, and you have an account. And we have meta transactions and other services to kind of allow you to interact with the blockchain without needing to kind of fund it with NEAR or other tokens initially. So we kind of have like this freemium model where you can start interacting with services without needing to pay day one, where you don't even know why the hell you're like buying all this crypto yet. Now, worth mentioning, there's also other tools like Keepon that allows to onboard people with links and kind of give some of the similar experiences. There's trial accounts, which allow people to kind of have limited for example, limited to specific apps, way to start using them without, again, needing to pay for anything. So there's like lots of tooling that's available for developers now to really onboard users really quickly. So let's see how it looks, right? So I'm not going to go through onboarding per se, but I'm already logged in. And so when you do kind of come in to near.org now, and maybe I'll show near.org incognito mode first. So this is kind of what you see. And the cool thing about this, everything you see is coming from the blockchain. So this is first blockchain website that's powered by blockchain. And you can actually create accounts and do all the blockchain things on the website versus going and like using some external wallet and figuring out what the hell is going on, right? So, and when I say it's coming from blockchain, if you go to develop mode tab, you can actually open up the details of the current page and see the source code of the page itself. So you can actually see how this page implemented. The source code coming from the blockchain, like the actual source code is stored on Near, and you can see the kind of commit history, the changes to the code directly here as well. And so that it's almost similar to GitHub, but it's powered by blockchain. You have kind of cryptographic identity. You can ensure that it's built, for example, in this case, it's a homepage for Near.org, so it's built by Near. But you can see kind of who it's built. You can have discussions about it. You can, over time, pull requests and other functionalities come in there as well. So this is kind of really allowing you to discover kind of how things are built, and then you can always go and navigate and see which other components it uses. So when I'm talking about composability, again, what smart contracts did, right, is like it's really easy to start calling other smart contracts and kind of depend on them because they will be there, right? They will not disappear, they will not go down. Similar here, because everything is stored on blockchain, you can actually depend on other components really easily. And as you depend on them, right, so for example, somebody built an image functionality, and image functionality includes in itself the NFT image or IPFS or Arweave or number of other services, right? So it kind of handles all of this complexity of rendering an image, which can be NFT or something, and you don't now need to re-implement that, right? And you can depend on it, and you can bind a version or continue actually getting updates as it evolves. And so this is kind of allows you to really quickly build new experiences. And I'll show kind of how this looks in practice. Now, I mentioned the important part is, I think the discovery, the interactions especially like we less and less use app stores, and we more and more actually discover through social feeds, through interactions with friends, through actually figuring out what other people are using. And so that's why, and also like, obviously, as blockchain community, the fact that we're using Twitter, Discord, and Telegram, 3 very centralized services for all of our communities, also seems very suboptimal. So here we have actually we call it Near Social. It's one of the applications on top of the boss, and it allows to actually have all of the kind of social interactions as well, cryptographically secure, owned by the user, and kind of powers the homepage when you logged in as you're going, right? So you have people following activity, etc. The interesting thing here, this is also kind of because it's cryptographically signed for every message, as we're going into this AI world where things more and more will be generated, this also ensures that you actually know who generated what content as they signed on it, and you can actually kind of have the provenance and supply chain of data, which I think will become more and more important in the future. So now from there, you can go and see what other applications exist, right? So there's kind of over 140 applications already, and it actually spans everything from DeFi, news, media, developer kind of communities, NFTs, etc. Right? There's also a bunch of stuff for Ethereum and EVMs and layer 2s, which Matt and MJ were showing yesterday. So I will not go too deep into that, but kind of just as an example, to also show the search, you can search for like something like Lido, and there's I think the app that shows you all the Ethereum apps, but you can open an application like this and kind of interact with it directly from near.org. So you can use applications of different blockchains directly on near.org because it kind of renders users and kind of abstracts out the complexity of these blockchain interactions. Now, I mentioned the gateway concept, right? So we are near.org. It's one of the gateways. It's kind of designed to feature what Near kind of blockchain operating system providing, but you can actually either build your own or launch a kind of a customized experience, right? So one that's kind of maintained by third party is called boss.gg, and it's really designed to kind of showcase some of the more Ethereum experiences. And so this is, for example, a ZK sync, right, page, which allows you to bridge and to swap directly on this page. And it exactly works the same way. You can go and actually, look at the source code, fork it, start interacting with it, and building on it. So when I say fork it, right, so I mentioned like if you're looking at something, you can always view details, and you can fork. And so you can open up and actually see the source code and kind of render the preview. And so just to show you an example, I was kind of playing around before the talk. So let's say you have the social feed, right? And you're like, hey, I really like the social feed, but I think it's kind of not very informative. I don't know who these people are. So let's insert a widget that actually provides us more information about this user. So it's like profile page sidebar. And so as we add it, right, like you re-render, and you can see the post and the information about it, and how many followers they have, et cetera, directly here. So the idea is like you can really quickly kind of iterate and see kind of, as you code what you're building, and navigate different components and pull them in as you're building. So this is all cool, but if you're an entrepreneur, if you're a hacker that's really interested in building something, like kind of let me tell you a little bit of like the holistic picture, right? So imagine we have a hacker that at the hackathon and really wants to build a new Web3 fitness project. Well, so they want to build a gym membership, and they want to kind of have individual and group experiences, and they want to use Web3 to really engage and create kind of loyalty and motivation for people. So there's 4 steps to build a new product. The first one is to test a hypothesis, right? I mean, at the end, the idea is just a hypothesis that this is something people want. And so you want the quickest way to get to, like, is this working or not? And so your kind of key KPI, right, is speed of learning, how fast you can actually put this in front of users and get some feedback and actually iterate. And so the cool thing here is exactly this, is that because you have all the services, you have all the scaffolding, you have already a platform where users are, you can actually really quickly go from few different pieces of existing applications, pull them together, and build your app, right? So let's say this fictional hacker, Idris, has set up a profile. They looked for some NFT marketplace. They found Mintbase. They found they have this cool photo sharing app, Minsta, that they can actually fork and leverage for their own minting NFTs from after you attended the gym, and actually kind of to commemorate your attendance. And so they forked this, modified it, and boom, they have as you finish your workout, you take a picture, it mints an NFT, and it's just a component and like serves that as a badge of your enablement, and it's just a component inside the kind of existing blockchain operating system, but you can navigate it through near.org. So you can start sending this to people and kind of get people to start interacting. So the idea here is really like quickly interacting, prototyping, finding existing pieces, pulling them together, and it's all JavaScript, including like if you do need to add more smart contracts, Near supports JavaScript. The middleware aggregation data called Query API also launching with support of JavaScript. So you can actually do now full end-to-end JavaScript applications and really simple developer environment, right? You can do a lot of things just directly in the browser. There's also VS Code extension. So now that you built kind of prototype, you want to see if people are really interested in like are converting. And so you want to get to few customers or user like super fans that actually love what you're doing. And so kind of the cool thing about this is like as people starting to find your app, let's say through various means, they can also start discussing and kind of commenting directly on the app itself, right? And so you can have those discussions there. You can use KeyPalm, you can use kind of various tools now to onboard new users, right? So you can actually get share links that convert people directly into your app and start interacting with it. You can have, if you have an email newsletter, you can leverage that to actually send everyone a KeyPalm. And so you can have all those things kind of really gaining traction and seeing how this works. And as users sign up, they just need to enter an email and kind of set up an account. As well as, because it's all part of the system, right, all the other platforms that exist that have blockchain operating system installed will kind of surface your application, right? So Near.org being one, but also Boss.gg, Near Social, et cetera, like there's already 5 or 6 kind of gateways. They all will surface your app if people search for fit, or if maybe you have some interactive social experience, and as people kind of comment and publish about it on the social feed, right, people can navigate from there directly to your app without needing to go through like another website, log in, and start doing this before you are ready for that. So built-in feedback loop, you have kind of really easy onboarding for people who are not in crypto. They don't need to have crypto to start using this. They can mint NFTs or interact with your app, start getting your loyalty points without needing to have transact like Near or Ethereum or whatever for transaction fees. And it's easy discoverability across the stack. Finally, you want to retain the customers, right, and users. And this is one of the biggest Web3 challenges. Right now, because of this wallet kind of experience, if you're building an application, you have no idea who your users are. Like people just come in, connect with your wallet, interact with the smart contract, and you, even if you have Google Analytics, you have no idea what's going on. So here, the important part is how to re-engage, right? How to create subscriptions, how to get notifications, how to create a captive audience that you can interact with. And so there are a few things. One is, continue building in more social features so you can actually engage your users. But the other important part is notifications, right? So there's a kind of infrastructure for notifications that works both, kind of with apps it's easier, but importantly it works with mobile web, which is a recent development on iOS side. And so it allows to start actually an application to push notifications to the user who subscribed to it. And so that's really powerful because it enables you to have hey, we have an update, or we have a new event, or we have a new competition running where you can win something. So you can have marketing campaigns, you can have engagement, you can have kind of updates all in one, and works directly with all of this Web3 infrastructure and users in control of what they're receiving. You can also then go and deploy your own gateway, right? So, this all was still serving through Near.org, through Boss.gg, through all these places. But at some point, it's hey, I actually want my own website. I want to customize some of the how it looks on a high level. So you can really quickly deploy it. It's actually 2 minutes, and to set it up, and boom, you have your own website, right? And you can customize the logo and kind of all of the experiences on top. So foster community, more ways to re-engage users, and kind of full customizability, as well as kind of for the overall look as well. Finally, you want to grow, right? So you want to get more users across different communities. You want to expand to other experiences, and you want to grow to other geographies. And so really cool things you can do is actually start interacting with other communities. For example, there's sports NFTs that exist on other chains. You can actually leverage that to and have a campaign around like, hey, if you have this NFT, you could get like a discount or whatever as you're interacting with your app. Right, so this allows to kind of start linking in with other communities and onboarding them. You can work with other existing apps that actually can drive traffic to you, right? So Sweatcoin is a great example. They have millions of users that are actually engaged and looking for more ways to engage with the ecosystem, and it's also very matching audience because they're into fitness, and so you can actually like market to them, give them a discount, and again, we launched One-Click Connect, which allows to directly from the app be logged in. Like as you open your app, you already logged in, and you don't need to go through this process of kind of creating a new wallet or connecting to a wallet and figuring out that Sweat is actually a wallet and do all this complexity, right? And finally, with geography is the really cool thing of this gateway is you can actually start internationalizing them. You can have other people translate it and kind of fork your component and translate it to other languages, and you can actually kind of surface that on your side, or people find them through kind of language-specific gateways. And I think like this actually will continue evolving, and we'll have more internationalization support in this. So scale your project, work with any chain, right, with any community, with any other kind of Web3 interaction, extend to any experience, link to other existing Web3 apps, and reuse and kind of fork and really open up the economy on top of it. So kind of this is what we call community commerce. It's it's a social interactions, it's digital value, it's kind of really active participation coming together in this blockchain operating system, and allows you to go from hypothesis to kind of prototype to engagement to market expansion in a really easy way and really build your application quickly. And just to mention, like if you are doing this and you are building a startup, one of the apps that actually is already launched there, it's called Near Horizon, and it's really to accelerate your Web3 startup. So it comes with a lot of tools, and there's VCs as well as marketing agencies, legal agencies, all kinds of resources for Web3 startups to really grow and expand from there. And so it kind of serves as like an accelerator platform. They also work with Outlier Ventures and a few other actual accelerators underneath. So Near started as blockchain, and kind of through the time has been continuously evolving, right? Now it's not just a blockchain, it has data platform, multi-chain interoperability, social graph, composable front ends, all of these pieces kind of coming together. And that's why we're calling it blockchain operating system. So I'll just finish on, there's Boss Bounty and kind of Near Protocol bounties. Check them out if you're hacking, and good luck.
All right, next up we have Dennis and Adam from MakerDAO. They'll be doing a talk on building truly resistant front ends for Web3 in 2023.
Nice. All right. Wow, it's so good to be here. Still kind of crazy to realize that we're in Seoul. Very grateful, so thanks to Erica and the team for inviting us. My name is Dennis. I'm known as 0x Dennis online. This is my teammate Adam. We are with Jetstream. Jetstream is an independent product team that's part of the MakerDAO ecosystem. And today we're going to be talking about how to build resilient front ends, because that's what we're focusing on at Maker. We're building open source components that you can use to build and deploy and host and maintain open source front ends for the MakerDAO ecosystem. So I'm really curious, like how many of you have ever like built some kind of web app or like a front end? A few over there, of course, some teammates, but also some others. Nice, that's good. Because yeah, I mean, I hope this will resonate and maybe we can have a little discussion after the presentation itself. Before we actually dive into the details, I want to start with some headlines that might be familiar to those of you that are in the Ethereum ecosystem. Yeah, some of these are quite bad, so I actually hope you're not involved in any way. I'm pretty sure you all remember this one. This is the Arbitrum airdrop. Yeah, that's actually not that long ago. So what all of these headlines have in common is that they were all caused by some kind of vulnerability or single point of failure that's not related to the blockchain or the backend, right? The smart contracts were operating fine. There was actually something wrong with either the front-end code or hosting infrastructure or maybe something like DNS or any tooling that they were using. And it's kind of the point that we're trying to make, because what we've been seeing in the Web3 ecosystem for, yeah, as long as we're in the space, is that there's this hyper-focus on the blockchain and smart contracts being like trustless and yeah, very resilient. But then we build these front ends and these apps, and we're just using AWS, and we're using all of these resilient, or these, yeah, let's say centralized and quite fragile, yeah, infrastructure and service providers. And the thing is, this, if any of those dependencies fail in any way, right? If there's some kind of, yeah, if it's overloading because you have a lot of users, or if there's some kind of vulnerability higher up the stack, then that's actually going to make for vulnerable users. But also the DAO, it can be, yeah, can be at risk. So we actually believe that we need more resilience higher up the Web3 stack, and that's what we're building towards. And the good news is that, yeah, at this point in time, the Web3, let's say, infrastructure and tooling landscape is very rich compared to a few years ago. So yeah, there's actually a lot of ways to build resilient front ends, which is yeah, what we're focusing on. So we get this quote a lot of times, like, why don't you just deploy your front end code on IPFS, right? That's like a very like overly simplified statement. I mean, it works if your front end is very simple and it's just like a static web page for making smart contract calls. But if there's something more complex that you're working on, right? If your app is more complex, so for example, if you have a lot of data sources and you need to aggregate all of the data in the app, and you have to like, yeah, use frameworks, or you're dependent on like dynamic server-side rendering, or maybe if you're like depending on legacy infrastructure, right? If your app relies on things that are still running on Web2 infrastructure, then you can deploy the client-side code on IPFS, but it's not going to really achieve resilience, right? You need a more holistic approach. So our team, we have first-hand experience with this, because we've been working on the Maker governance portal, which is the official governance front end for Maker. It's quite a complicated application because it's not just a simple front end for making smart contract calls. It's actually some kind of dashboard where people can view all kinds of blockchain data, but also historical blockchain data and like metadata that's not hosted on the blockchain. And it's obviously a very critical application to the health of the MakerDAO ecosystem and also to the users. And yeah, the app, like the V1, was built quite a long time ago, before we were really talking about front-end resilience and before we had things like, I don't know, subgraphs and things like that, right? So we ended up using centralized infrastructure for some of that, and also things like related processes. So for example, the processes related to managing profile data for the delegates, that's kind of relying on things like GitHub. So if there's problems on any of these dependencies, then that would directly impact our application. And yeah, we've been very aware of that, and I'm very happy to say that the future for Maker is going to be more focused on resilience. MakerDAO has been undergoing this kind of shift on an organizational level, but also on a product level. Yeah, there's going to be more published in the upcoming months, but basically the new strategy is called Endgame. And one of the newfound principles for Maker is to have more resilience, both in the organization, but also on things like front end, and also, of course, on the protocol level, as that's what it's been known for. So yeah, front-end resilience is a default requirement in the MakerDAO ecosystem as part of the endgame strategy. And we're actually pretty sure that this is going to be a default requirement for the entire Web3 space over the next decade. And it's kind of refreshing to see that at this conference, we've already seen quite a few talks about building resilient and composable front ends. I mean, Ilya's talk, that was more focused on the near ecosystem, of course, but it's just very refreshing to see that we're not only talking about the blockchain and blockchain security, but also looking a bit higher up the stack. Yeah, I'm going to hand it over to my teammate Adam, who's going to talk a little bit more about our approach towards building these resilient front ends.
Okay, so if we look at a simple diagram here of your typical Web3 app, you of course have your backend layer, which is going to be the blockchain network of your choice, and then you have the front end layer. And within the front end layer, there's sort of three areas of consideration. You have your application code base. So this is going to be all the code that's producing your UI and contains the logic for interacting with the protocol in the back end. You have your hosting infrastructure. So where is this code living? Where is it being run from? And then you have all the data within the application itself, which informs the user about the protocol and about the transactions that they may be about to make with the protocol. So we can dive into some of these. So when we're building new apps for MakerDAO, we're really focusing on building the app to be compatible across multiple hosting options. So of course, you're going to have your traditional Web2 hosting. This is the default. This is pretty much how all web apps are hosted. And a lot of times when we're using a Web3 app, or an interface, it is still hosted on Web2 infrastructure, which is fine. It works until it doesn't, until there's problems. But so when you're building the app, we think it's important to consider making it compatible for hosting on Web3 infrastructure. So today that's things like IPFS, Arweave, tools like Fleek that allow you to deploy these applications to these types of decentralized like file storage networks. But this is something you want to think about from the beginning because there are some limitations if you want your app to be able to function properly on these in these environments. For example, like you can't rely on having a web server or like doing any kind of server-side rendering for your page. So you're essentially just serving static pages. And so when you're building and designing your app, these are things that you want to consider ahead of time. In addition to using your app on a hosted server somewhere or a network somewhere, we think it's also important to give the user the ability to run the application locally on their own machine and not have to rely on someone else hosting it for them somewhere. So usually this looks like cloning the repo for the project from something like GitHub, doing some small configuration, and then using the command line to run that locally. And if you are familiar with these things, it's usually not super complicated, especially if there's good documentation, but you do have to be familiar with like using a command line, and not all the users have that technical experience. So taking this a step further, we also decided, let's see if we can give people a way to run the app on their machine in a local environment, but so that they don't have to know how to use a command line. And so using a package that was created by Versal, it's called PKG, we actually found a way that you can, from the project, output like a single file that you could then make available for the user to download. And once they have this file, all they have to do is open it on their machine, and the app should work the same way it would work in a hosted environment. So I have a short little demo just showing that. It's a really simple script. It basically just takes the built website, like the folder with all the files for the app, and then produces these files that they can run. And if they download that, all they have to do is open the file. It'll open up in their browser on their local host, and assuming it was configured correctly ahead of time, everything should just work out of the box for the user, and it's running on their own machine. They don't have to worry about yeah, a hosted instance of it somewhere. So yeah, the takeaway here is like give your user some options, make sure that the app's not only available in one specific place, and if that goes down, then there's no way to access that application. Moving on to the application code base. There's a few things here that are mostly standard best practices in the space, but of course you want your application code for the front end. We believe it should be open source. I mean, these are applications that handle a lot of financial value. Everyone should have an idea of like what code they're trusting when they send these transactions. And it helps to have obviously documented code base so that it's easy to read for someone who's just jumping in and wants to see what's going on there. As you mentioned, it should be written so that the configuration is not overly complicated. Hopefully it doesn't rely on like hard to obtain API keys or database credentials, things like that. And then modular and extensible code. So an example of this specific to MakerDAO is that when interacting with the MakerDAO protocol, there's a lot of smart contracts involved, and it requires like a good amount of time to familiarize yourself with all these contracts, which functions to call and how to call those functions, like passing the arguments that are formatted in a certain way. And there's really a lot of overhead there if you're not familiar with it. And so we abstracted a lot of the complex logic into these easy to use React hooks into its own package. So things like interacting with governance, interacting with vaults, DSR, almost anything related to the protocol. We're providing a package of React hooks to make this like pretty straightforward for an average person, or average developer, I should say. And yeah, so if someone wants to make some additions to the existing code base, it shouldn't be that hard, even if they don't have that pre-existing knowledge of the contracts that need to be used. And if you wanted to build a new front end to interact with the Maker protocol in any way, this should make it a lot easier. I mean, you don't have to spend all the time learning about the contracts behind the scenes. So the idea here is make it easy to replicate these front ends, make it easy to make changes for developers. And then lastly, application data is obviously an important part of the app, and there's a few different types of data that you have to consider when you're loading data into the application. So start with real-time chain data. This is kind of the most straightforward. This is going to be data that you're getting, like the live state of the blockchain. You're getting it directly from an Ethereum node, or yeah, this is typically Infura or Alchemy or something like that. But when you go to an app like Uniswap or something, for example, you don't really have a say in which node that you're sending your data to. It's usually provided by default by the creator of the app. And usually that's fine, but there have been times where like certain nodes go down or certain providers are having a hard time handling traffic. And so we decided it would be a nice feature to have if the user could, in their configuration, maybe set their own RPC node that the application will talk to. So have a short demo for that as well. This is just a page within an app that pulls price data from Maker oracles, which is stored in smart contracts. So it's just a simple call to read a smart contract's value. And you can see that by default, it's going to Cloudflare ETH, which is a public provider that's available. But if you navigate to our settings page, there's an RPC section, and for each chain within the app, we have an option where you can use the public provider, or you can change that and put in a custom one. And you can actually send a test, make sure things are working. You can see there that it went out to, we put in an Alchemy URL here. And now if we navigate back to our application and go back to like the oracles page, you can see that it's fetching the data, but now it's sending those requests to the RPC URL that we inputted. So yeah, it gives the user a little more more freedom into where they want to actually get the data that they're interacting with on the page. Next, you have index blockchain data, which is like your historical data. So these are things that happened on chain, but was maybe a week ago, months ago, years ago. And this data can be pretty difficult to like fetch directly from a node. It's not that efficient. You might have to sift through logs and logs and logs until you find what you're looking for. And so the solution to this on almost every app is that if you know you want this data from in the past, then when it happens, throw it into a database so that next time someone comes to the page, all we have to do is ask the database, like, hey, give us that information. It makes for a better user experience, but like if you think about where that data is sitting, like for us on the governance portal, the solution that we came up with years ago was to have a monitor to watch for these events, and when they happen, we put them into a database. But that database is just sitting on AWS server, and you know, AWS, yeah, it's online most of the time, but it's possible that it could go offline. AWS has had outages. And another thing is that if people want to run their own version of the application, they either need access to this database, so it has to be totally open, or they need credentials to read from it. And it's not easy for them to create their own copy of this database. It's hard to do, and it's also expensive. So we found that a stronger solution for historical data is to use a network of decentralized indexers. There are a number of projects working on this. I think subgraphs from the graph is like the most well-known, at least at this point. And they do have a hosted service, which is basically probably sitting on AWS server as well somewhere, I guess. But they also have a decentralized network that they're building out, which today works. And so we find that this is a much stronger solution for building resilient decentralized front ends, because it's no longer relying on one database sitting somewhere out there that if it goes offline, that data is no longer available. But now it's an entire network of people that are indexing this data for the users. And if a person wants to create their own application for the protocol and wants access to this data, it's there. It's on the decentralized network. They don't need an API key, or it may need an API key, but they don't need like credentials or something. It's an open database for them. So lastly, we have off-chain data, which is a lot of times like used for metadata. An example of this within the Maker context is like for vote delegates. Delegates are represented by a smart contract on chain, which allows people to deposit tokens into it, and then the delegate can vote in the protocol with those tokens. But the contract itself contains no information about who that delegate is. So things like their name, their profile, what they stand for. And people who are delegating their tokens, they want to know this stuff. So we have to find a way to attach information to them. And often it's pretty expensive to put all this data on chain. So people end up using any kind of content management system, really. Like, could be GitHub, could be, I don't know, whatever CMS you can think of. But we used GitHub in the past for attaching data to delegates, and then we have run into issues where either GitHub was down or we were getting rate limited trying to ask GitHub for that information. And so, the smart contracts were still there, but anyone who came to the portal wouldn't know who they're giving their tokens to. So we did some research to try to find for a more resilient solution to this. And what we came up with is leveraging a decentralized file storage network like IPFS. The reason for this is the barrier to entry for IPFS is pretty low compared to some of the other solutions that are similar. it's very easy to run a node and pin files. And there are also a lot of pinning services available that are not that expensive that you can also leverage too. So you can have multiple IPFS nodes pinning files for you. And then there are also multiple gateways to access this. So you know that if one node goes down, there's likely another one with this file. And as long as it's pinned somewhere, then you should always have access to this file. There's one complication with this is that when you store content on these decentralized file networks, like basically they give you a hash, which serves as a content identifier for being able to find that information or find that file. And it's immutable, and metadata is often changing. So what happens then if you want to update the metadata, someone's profile, or add something new to the file? You can't really modify the file and still have the app know where to find it in the app code itself. So a solution we found is to attach this data about the latest metadata on-chain to something like an NFT. And so like ENS domains are NFTs, and you can attach like text records, content hash to these NFTs. And so we have a system now where every time we update our metadata for the protocol, we send a transaction to a protocol-owned NFT, an ENS domain, and we store a reference to the latest metadata. So when the app loads, all it has to do is check this NFT, get the latest ID for the latest metadata, can fetch it from IPFS. We know that it's going to be available because it's stored on multiple nodes, and this way we have a way to be confident that the app can always have this metadata available, even though it's not directly on-chain. We only have a reference to it on-chain.
Yeah, so Adam just talked about off-chain metadata and also talked about how to use things like NFTs to make that happen in a more resilient way. Another approach we've been looking at is trying to understand how we can potentially move some of that off-chain metadata actually on-chain. There's actually quite some tooling that you can use for this. We're now working with the HETS protocol team to try and understand how we can move some of the governance metadata for MakerDAO actually on-chain. The cool thing is that, so the thing that HETS protocol has built, it's like an NFT standard for tokenized roles and responsibilities. So instead of having some kind of off-chain metadata set that describes all of the roles and like things like names and profile pictures of all the actors in the governance system, you can actually use something like this. So yeah, the truth will always be on chain, and then you can have a subgraph index the HETS tree, and make sure that you always have like an up-to-date version of the truth, right, of the organization in that sense. And you can even take this a step further by then also using this for things like multi-sig access and like maybe even Discord access. So you can really use this as some kind of like way to map out and manage your organization. And what's especially cool about this from our perspective is that you can also have a more granular approach towards managing the metadata, because as Adam said, like the metadata often changes, right? That's the main thing about the governance metadata especially. So if you can have, for example, delegates and voter committees manage their own metadata fields, like, I don't know, like names, biography, that kind of stuff, then it's going to be, you're going to be less reliant on some kind of mandated actor or gatekeeper to manage and upkeep all of that data. And you can do that in a more granular way and also have it represented on-chain directly. So that's another thing we've been working on. Yeah, so another important principle here is to be very transparent about which data sources your app uses, and maybe also let users decide which data sources to trust. Like, it really depends on who you're talking to. If you're like talking to some kind of anon dev who is very keen on their privacy and they really don't like trusting any, let's say, infrastructure layer, then they should have the option to only use those data sources, right? Or at least be informed about the fact that they're using other data sources. We came up with this concept called trust levels, which is a way to like explain to the user the reliance on certain data sources and also the degree of risk that you're taking or the degree of trust that's involved for that data source.
Yeah, so we have a quick demo of this concept and what it looks like today, but still evolving. But if we're on our delegates page here, and as the mouse moves around, you see this green indicator. You can click on it, and it says data source information. It tells you this data is not directly sourced from on-chain, but instead from aggregate data from centralized or decentralized indexers. But then it actually lists exactly the source of the data that's on the page. And so in this case, it's coming from a subgraph, and it says trust level 1. Yeah, you can actually go to the source. But if you click trust level 1 to see, to get more information about it, it'll tell you like what trust level 1 means, and then you can view the settings. So here, within the settings, you can read about the different trust levels that we've defined, and you can also change them. So by default, the app has the highest trust level. It basically says we trust anything that the developer has put in here, but it can be changed. You could maybe say like, I don't want anything from like random third party, or go down as far as like, I only want data that is coming from a call to a node, an RPC node out there. And so if we change it back, or we change the level to 0, if you navigate back to the delegates page, now you see these warnings around, and it's pretty obvious, okay, like what is this? And if you click it, it says, you know, this data includes sources that are not trusted by your current trust level of 0. Again, shows you the source, but highlights that like you've said that you don't necessarily trust this data source. And so it's still something we're evolving and working on the UX for, but yeah, the idea is like being very transparent about where the data is coming from.
Yeah, and this is obviously a proof of concept app, so it's still, yeah, we're just using this to explain what we're working on, but yeah, we're really looking forward to, yeah, implementing this further in the app and also like more granularly, so you can really, I don't know, like hover over any data point that you see in the app and then immediately understand where the data came from, have a way to easily explain like the amount of trust involved for that data source, and also allow to immediately like view that data file or whatever in a different environment. So yeah, to wrap it up, basically it's all about redundancy, right? So we talked about having compatibility for a range of like hosting and delivery options, so that both the front-end operator can decide, like, do I want like a fully regulatory compliant Web 2 hosted instance, but you can also go like the decentralized route and use Web3 tech, or maybe even distribute the app to users themselves so that they can run it locally without any dependencies on hosting. Also make the code very easy to fork and deploy, right? So make sure it's well documented, make sure it's easy to configure, so that you actually don't have to rely on a single instance, and you can expect the community to pick it up and fork it and make some tweaks and actually have some kind of ecosystem. That's really what we're trying to achieve for Maker also. Free your RPC, right? So make sure that you allow people to make changes to which RPC they're using. Maybe even make them aware of the fact that they're relying on an RPC endpoint provider, and for the decentralization maxis, allow them to connect to their local ETH node. Of course, leverage Web3 stack further up the stack, right? So if you're dealing with multiple data sources, try to find a way to not rely on centralized Web 2 infrastructure, which is very prone to things like outages, but also like censorship, and make sure that let's say, platform or tool or infrastructure that you're using, make sure it's redundant, right? For example, we talked about IPFS. We've also looked at some other file storage networks in the space, but IPFS is definitely the most mature one, right? It has a lot of gateways, and there's a lot of redundancy inside of that ecosystem. And that's really what it should all be about. It should all be about redundancy in that sense. And that's what the approach that we're taking for Maker. We want to leave you with this little cheat sheet that we've made. Like, you can use this to assess the, let's say, resilience of any front end in the Web3 ecosystem. So I don't know, if you're in crypto, you use a dApp, maybe ask yourself these questions, try to understand how the app is working, right? And where the data comes from. And yeah, this will make you more aware of, let's say, the amount of trust involved when you're interacting with a dApp, right? Because even in crypto, you're not talking directly to the blockchain, right? Usually you're using this app, which is usually very complex. It's not only like a static front end for making calls. It usually involves a lot of data sources and a lot of reliance on infrastructure. And yeah, I think the first step is for us all to become more aware of this and more critical. And then hopefully, yeah, as we said before, front-end resilience will become a default requirement for the space. Yeah, so if you want to stay up to date about our work and also, yeah, make sure to know whenever we launch the front ends for MakerDAO. Follow us on Twitter, we're JetstreamXYZ. We literally just, let's say, rebranded our team. So we published our proposal to the MakerDAO ecosystem yesterday. It's quite exciting time for us. Yeah, and we're now happy to take any questions or maybe have a little discussion about the subject. So thanks a lot.
All right, guys. Next up, our speaker is actually sick, so we're going to take a 30-minute break, and then it'll be the Ethereum Foundation. So he'll be starting at noon. See you guys then. All right, we are back. Next up, we have Chi Chang from the Ethereum Foundation. He'll be doing a talk on Halo 2 circuit developer experience.
Thank you for the introduction. Hello, everyone. Thanks for coming to this talk. So, yeah, I did this talk last year end at Bogota DevCon, and now we're at like June 2023. I feel like this talk is a little bit late. Like after half a month, like we now have like Nova, we have like all these new proving systems and like new languages. But I feel like there's still a need to talk about Halo 2, because if you want to contribute to ZKVM or like some low-level language implementation, some knowledge about how Halo 2 works was very helpful. And also the new proving systems, Nova, Hyperblock, and everything are built on top of Halo 2. So let's begin. So about this talk, I will be talk about some building blocks of the Halo 2 circuit, and also the design mindset for the circuit implementation. Like most of us are not like cryptographers. Most of us are developers. We're building applications, and we usually write a programming language like Python, JavaScript, Rust, but Halo 2 is a very different beast, and it requires different mindset and thinking about to write your present application. And so there might be some challenges, and I hope some of our tricks and tips can help you navigate through this. And about me, I've been working on ZKVM community version in PSC for 2 years. And the goal is to build a L1 execution layer proof. And so our goal is not for ZK rollup. And we've been working with Squirrel and Tycho, and they're building ZK rollups. And we built the whole project on top of Halo 2. And a quick reminder that our project is licensed in MIT and Apache 2.0. So feel free to use it, fork it, modify it, do whatever you would like to do. So a little bit primer on the ZK proving. So we have two parties, one prover and one verifier. They agreed on some algorithms, and prover at the proving time, they can claim they have some inputs and derive to some outputs. And the verifier can read the input, output, and approve, and then convince that the output is correct without rerunning the program again. And that's how zk-proof allows us to compress the computation, or you can hide some information in the computations, and you can let the verifier with low computation powers to verify that computation. And let's unwrap this a little bit. So we have two scenarios. One is setup time, and one is proving time. So setup time, the prover and the verifier agreed on some algorithm, and you, the developer, write that algorithm and express in this grid, in this weird Sudoku game, like you express that algorithm in that grid. And then we will turn that grid in terms of verifying key and proving key, and distribute them to the prover and the verifier. Then at the proving time, the prover can run that algorithm, can fill in some inputs, all the middle computation traces and the outputs. And then the prover will create a proof and then send to the verifier. And the prover uses the proving key to generate a proof, and the verifier will use the verifying key to verify the proof and determine the proof is valid or not. Now, the circuit developers have very different brands. So usually as a normal developer, we work with languages like Python. We define our computation in variables. We might determine on some conditions and then branch our programs into different parts. We handle our computation in terms of CPU runtimes. But as a circuit developer, you are working with the computation traces, which is the input, all the intermediate values, and the outputs, and they're laid out as the values. And then what we design is a set of mathematical constraints, and then to determine if these traces are valid or not. So I would say there are three elements in the circuit developing. One is the computation trace. The other are constraints. And the third one, like I hope this can go away soon, like is arithmetization. So what is the computation trace? It's step-by-step values to derive the computation from the inputs to the output. For example, if I want you to count two numbers multiplication with millions, and you might use your textbook algorithm and write all the computations, and those middle values are your computation traces. And for the constraints, we define what's the valid path of the computation trace. There are some valid value you can fill in the Sudoku board, and there are invalid values. So if we over constrain or under constraints, we will introduce some bugs. If we constrain too much, then there are some valid computation the prover is not able to perform, and then we'll have a completeness bug. And if we under constraints, then the prover can convince the verifier some false statements, then that's a soundness bug, very serious. And the last one is the arithmetization. like we have to express those computation traces in numbers and the constraints in math and equations. So those are the difficult part. So let's unwrap these three elements one by one. The first one is we want to express the computation trace into into some formats that the computer can parse and understand. So first, we have a grid like a Sudoku board. We organize it as some columns and some rows. And in each cell, you can fill in a number. This number is a finite field element. Usually, you can think it as an integer less than p, p a number. For example, if this p is 3, then you can input 0, 1, 2. But if you need to perform some like additions and multiplications, for example, 2 plus 2, then this you usually get 4. But like since we have this like wrap over property, then it will become 1. So everything in the cell is under modular arithmetics. And P is usually a very, very big number. It's 254 bits. Usually that's very enough for most of the applications. But like, for example, if you are dealing with EVM words, which is 256 bits, then you have to split the word into like two parts, the high parts or low parts, so that it doesn't overflow. So for the rows are fixed height. Usually it's 2 to the 16 or 2 to the 20 rows. Like the space is free, but it's capped. And you can like feel free to use as many rows as possible, but you are not able to increase it to too many rows. And for the columns, you are free to add many columns with some additional cost for prover and verifiers. So yes, so this is the grid that we can lay out our computation traces. And now, like we now need to define there are different types of columns. A column is a polynomial, and like it kind of compress all the value in that columns and into a elliptic curve element. And but there are some like different types of columns we need to pay attention to. First one is the fixed column, and this one is created at a setup time. You assign the value at a setup time. It's visible to the verifier and also to the prover. You can think it as part of the circuit constraint. Yeah, the printed Sudoku values that you must satisfy. And the other column is the advice column. This is the prover assigns value in these cells in the proving time. So usually the actual value is only visible to the prover, and the verifier only has access to the commitment or the curve element of that column, but they don't see the actual values in there. And so this is visible to prover and determined at the proving time. And the last one is the instance column. This is when you have some public inputs and then you want to share between like prover and verifier. For example, the Merkle rule of tornado cache, and you put this value in the instance column, and this is also determined at proving time and visible to verifier. So let's give a recap. So at the proving time, we filled the grid with the prover prover values, and the prover uses the proving key to turn this grid into a grid of computation traces into a snark proof, and then send to the verifier. And the verifier using a varying key, the verifier sees the proofs and all the columns and the values visible to them, and verifying the proof with them. Now we've talked about the computation traces. Now we can talk about how do we express constraints in Hello 2. So constraints define what computation traces are valid, and they are defined by relative positions. So usually you have a selector that used to enable or disable a constraint, and then this selector is a fixed column, and you have an expression like the equation there. It says the selector times a minus b next equals to 0. And this cells, you can put it in any relative positions. You can put it in like 20 rows later, or like 3 rows later, but or like some columns on the right, columns on the left, but they have to be in relative position. So we can give an example to show that. For example, this is a Fibonacci circuit. So we want to prove that the nth term of the Fibonacci numbers, for example, 1, 1, 2, 3, 5, and we can lay out this computation trace and the intermediate values in this grid, and we have the Y1. The Y1 should be the fixed column. I did the wrong coloring, and so we define the gate. The gate as a constraint. It has the selectors on the left, and then left value, right value, and the sum. And then they must satisfy the equation. If the selector is on, then left plus right minus sum equals to 0. Then we check it row by row. Like this one, selector is on, and so it must satisfy the right equation. And then 1 plus 1 minus 2 equals to 0. And this gate will scan through the whole rows. And then if it's on, then the constraint must be satisfied. And scan down to the last row. The selector is disabled, so the left, right, and sum they doesn't have to satisfy this expression. So this is another way you can write your constraint. We save one column and move the constraint cells to the right next. And then we can do the scanning and check that this trace is actually valid. There are three types of checks in Hello 2. So one is using the gate to constrain the computation trace. The other one is the equality checks. So equality checks can let you glue two cells together, but they are defined in absolute position. So for example, we can glue this 10 to the 10 with this copy constraint. Also the 100 to the 100 with the copy constraint. So when they are glued, the value in the cell must equal to each other. And and there's also a lookup constraint, but I didn't include it here because that includes some complexity. And as the snark is a verifying computation technique, And so we're designing some like can't be evil applications. And to do that, we must assume that our actors pool is always evil. They are able to do anything evil, and we must argue that if they are evil, we can prevent them from doing evil things. So, so that's all the rule we have in Hello 2. Now we can look in some tricks. The first trick is, of course, limiting what kind of values you can input in the cell. So the simplest one is to multiply that. For example, you only allow the value 1 and 2 and 3 inside a cell. Then if that cell is x, and then you create an expression x minus 1 times x minus 2 times x minus 3 equals to value. So if you input value 3, it satisfies the expression. 2 is also satisfied, but 100 does not satisfy the expression. The output is not 0. 0 does not satisfy the expression too. So, yep, that's limiting the set of options. Now, the other trick is to convert if-else. So in your application, if-else is very basic building blocks for your application. Let's give an example. Like you have an algorithm, FOO, and then you have two inputs, A and B, and another input variable happy. If it's happy, then we perform addition. If it's not happy, then we perform multiplication. And for this circuit, we laid out some computation traces, and we input a computation trace to the grid, and then we define some copy constraints so that let's say we have A is 5 and B is 6, happy is 1 or 0, and the output is 11 if happy is 1, and if it's 0, then the output is 30. So we can define the expression like this. So you have happy times A plus B. 1 times happy is A multiplied by B, and minus output must be equal to 0. And if, as you can see, if the happy is 1, then the left constraint is enabled, and the right one, the A multiplied by B, is disabled. And if happy is 0, then the left one is disabled, and the right one is enabled. But there's a small problem in this equation. Do anyone see any problem? Okay, I'll get to the point. So the prover can witness the value happy to 3, so that it gets a very invalid output of minus 27 that you cannot ever derive from that algorithm. And why is that? Because we didn't constrain the possible value for happy. Happy is a Boolean value, so we need to add another constraint to constrain happy to be 0 or 1. Okay. Now we have if-else, and we convert it to the math expressions. Now we can converting some for loops. For a simple for loop, if the number of loop is deterministic, then you can just lay out the computation traces and make it fixed number of fixed number of grids. So this is very easy. But if the range, like if you don't know how many loops, or like this number of loops is determined by proving time, then we have a problem. Like we cannot glue them in with the copy constraints. We don't know how big the table is. So what we have to do here. So one principle is that like we are not able to prove infinite loops. Like there's only when you determine number of columns of your circuit, there's only so many computations you can prove. It's a fixed amount. It's capped. So we're not able to prove infinite number of computations. So we have to define the max possible of n. And then sorry. Yeah. So one strategy to do this is to have a one strategy to have a dynamic input is to let the prover witness the number of n, and define it as a variable r, and then but if we don't limit the number of the R, the prover can witness the wrong value and then give you a wrong output. So we can see some how valid computation trace like. So the left one is like if the n is 0, then we should have selectors of 0. But if the n is 3, then we should have three of selectors are continuously 1 and then 0 to the end. And the last one, if the n is 5, then we should have like 5 of selectors are enabled, and the last one is 0. And then so we can observe there's a state machine here. So if we start our algorithm, we can go to the path to add more values, or we could go to the padding no values, but we are not able to go through the padding to the add. So when you when the selector is 1, your next one can be 1 or 0, but once you enter 0, there's no way you can enter to the 1 again. So define a state transition. You can make sure this computations always run correctly. There is no way the prover can witness 010101 and like mess up your computation in this algorithm. So yeah, these are a bunch of details like to add some missing constraint to this algorithm. And the takeaway here is the in the CPU computation, when we do a branch, we just ignore like if you select one branch in the if else, then we just ignore the else branch or the other branch we didn't go. They won't be the overhead of your computation. But in the circuit, like if we have if else branch, we must leave the space for the prover to compute them, because you don't know, and you write the program at a separate time, but when you're in the proving time, you don't know which path the prover will take, so you need to leave the space for the both branches inside the circuit. And the last one trick is we learned in this March in the Vietnam residency. We have we have a boot camp, and we realized that like if we can express our computations in the recursive function, since we are verifying a computation trace, we don't have to really verify it from the beginning to the end of the real computation. We can actually verify it from the end to the beginning as long as the relationships and the structure of the computation is correct. So expressing the function in recursion has some benefits. That it's very easy to argue the correctness of the function. Like if you express in for loops or like your normal incremental computation, it's easy to mess up or forget or do it wrong with some variables. But expressing recursions is very easy to see if it's correct or not. So yeah, I still have 40 seconds. So some takeaway for this talk. So yeah, for a challenge for circuit developers, we are doing with computation traces instead of the actual real execution. So we need to flatten the computation path and leave all the space for the both if-else branches and all the branches of your computation. And we are working with the math arithmetics instead of bytes, so we have to deal with the finite field elements and math equations. And the last one is we are working with the prover that could be evil, so we need to prevent them from cheating the computation. We must be careful with the every possible invalid computation the prover can witness and convince you the wrong output. And some trick is that if we want to limit some, if we want to do the if-else branches, then use the this type of equations to do if-else branch. And for complicated loops, try to define your application as a state transition and define constraints for them. So, yeah, that's my talk. Thank you very much.
All right, next up, we have Makoto from ENS. He'll be doing a talk on ENS for your community.
Okay. There's a green one is next page and there's a back page. Okay.
Okay. 네, 안녕하세요. 반갑습니다. 제 아내는 한국 사람이기 때문에 한국에 많이 와봤지만 크립토 컨퍼런스는 처음입니다. Okay, that's all my Korean. I can make it. Yeah. Thank you. I was practicing this so many times so that I got lost in the subway, but I'm so glad, like, I made it. So hope it was well said. Okay. So today, I'm going to talk about topic is ENS for your community. And how many people actually hacking today? Okay. Yeah. If you are hacking, probably they are hacking. Okay, that's good because I saw so I didn't put code. So this is more of like I meant it's so non-technical. But if someone decided to hack suddenly, like after my talk, and if you wanna, get to know more detail, feel free to grab me or like I have some pointers to some of the repos. Yeah. Okay. And today, yeah, so, okay, actually, who has ENS name? Okay, that's great, great, great. Thank you. Who has subdomains? Okay, 3, 4 people. Yeah, so ENS subname, or we used to call like subdomains, been there. Oh, it's there. Okay, great, thank you. Been there since it launched back in 2017, but it's kind of less utilized, but we've made some changes to make it more usable. So today I'm going through like 4 use cases so that maybe for your next project, you could use some aspect of it. And so first, what is ENS subnames is that, so this is actually ENS name that, like, as you know, like Ethereum address is kind of hexadecimal, not user-friendly, so you can provide, yeah, human readable name like matoken.is. So I, in fact, have this so-called ENS card, which means pull-up NFT badges. So if you tap with NFC card, we can give the card to say badges to say we met together. So if you're interested, just come out to talk to me and then tap this. And also, yeah, but this is a subname that if you can see, yeah, makoto.argent.xyz. So this is one of the wallet. Does anyone know Argent? Okay, yeah, a couple of people. So Argent is one of the first wallet who decided to issue subname when they create the wallet. One of the, I think, onboarding issue is like when people create wallet for the first time, they have no crypto asset, so they had to send somewhere, but they don't really know where to send to. So it was a great UX improvement that Argent decided to issue subname for each user who onboarded. That was great. So, and another thing about subname is like, so to register .eth name, you need to kind of pay $5 mostly annual registration fee. That's mostly to prevent people from like kind of squatting. But once you own it, to issue subnames on the name you own, it doesn't require any registration fee. And yeah, as long as you have that name, you can issue, anyone can issue it. And that was a great way to onboard, as I said. A few things you might not know is .eth name is NFT, but subnames are not, and I will describe the reason later. And this is not just for subname, but like most ENS is known for name service on Ethereum, so you have to pay gas. So for that reasons, Argent now doesn't issue subnames because back into 2020, when like DeFi summer kicked off, people start seeing like 100 Gwei, and it's getting too expensive to issue subnames. Okay, so I'm gonna, oops. Oh yeah, so now I'm going to talk about one of a few ways to issue subnames, and first is called subnames as NFT. And so problem recap, the reason why it's not NFT comes down to the architecture of ENS. In ENS, it's have the hierarchical architecture. So like if you own the name and if you subname, the parent can always override their ownership. So if subname is NFT, parent domain owner can still override, which kind of defeats the purpose of like NFT being the kind of transferable. So that's why by default it's not NFT. And yeah, as you also know that ENS.eth name has expiration, and if parents get expired, children get expired too. And to overcome that problem, we spent like last 2-3 years to come up with something called name wrapper. And the name wrapper, as the name suggests, it wraps existing names. So you can wrap .eth name or subnames or even like a non-ETH name. Another thing you might not know is like you can actually import DNS names such as .com, .io, .xyz, and they are not NFT, but you can actually make it NFT. Wrapping DNS imported name has a bit limitation, the fact that you actually, if you re-import it, you can overwrite the ownership, but at least you can kind of see if you wrap it in an NFT, you can see it in your wallet. So it has some utilities. And also the reason you wrap is the fact that we add a few permission controls, which we don't have. And most important bit is, so we call it fuses. The idea is like fuses, once you burn it, you cannot revoke it. So like these one we call fuses. And one thing you need to implement is that basically the fact that parent can overrule children. So first fuse you need to burn is that control, you need to burn it. Then there's tons of ways to control how your name can be controlled, and there's like 5 or 6 of them. And by using them, you can create some certain combination of, like, if you can extend expiry and the parent cannot control, you can, by binding these two, it allows you to kind of sell as permanent root names. And also, if you burn these 4 combination of can extend expiry, parent cannot control, cannot unwrap, and cannot create subdomains, then you can kind of sell permanent names but prevent them from creating their own subnames. If you want to kind of have a limited issues of subdomains. And also, parent cannot, if you, by burning parent cannot control, you can also, you could write a contract to let out the names and the stuff. There's a quite complex, and to be really honest, like I think I have 100% grasp the whole capability of it. And also, it has a lot of kind of side effect of if you burn this happens. So there's a thing called fuse book, which will allow you to kind of interactively play with the various fuse conditions. So if you only burning this fuse, you can now burn this kind of fuse. You can experiment interactively. So that's the first one. And the other example I explained, you need to kind of be able to code by yourself. But this wrapped names, you should be able to control everything using our app site called app.ens.domain. So even though it's one of the most complex example, actually you can do it in no code. So if you want to try out, go to our site and try to burn a couple of names, fuses. And the next one is I coined the term called digital twins. And the use case is that who owns NFTs? Okay. Yeah, so, and maybe some people may be into, like once they issue NFTs and they try to craft a community around it. And a couple of the requests we received is like, can you create ENS subnames for each these NFT owners? And can you also transition the ownership dynamically, that if you have a punks and if you, person A has punks, and if you transfer to person B, can you make subnames so that it can transition? And the ownership as the NFT ownership moves. And it is actually possible using the so-called ENSIP10 wildcard. This one, the idea is that it's all kind of implemented at the client level, that if subdomain, such as in this example, it says 1.doodle.is, doesn't exist on a smart ENS contract, the client asked to its parents, doodle.is, to say, do you know anything about this subdomain? And by using this wildcard convention, you can actually create a contract which dynamically looks into the ownership of this, for example, Doodle NFT. And if it's owned by Doodle NFT, you can actually say one's ownership does belong to Doodle. So this kind of stuff, we knew it's possible to do, but we never had time to implement. But I think great things about open protocol is like all the ENS contract is open source, you can look into it. So one of the community member called Rafi.is, he's actually one of the great contributor to the ecosystem, and he gave some big contribution, but he played with the idea and he created something called NFT-owner.is, which allows you to kind of wrap names into, so not wrapping, but basically associated this gasless, by utilizing this model, it has something like, for example, if you want to give subname for Moonbird, in this example, it says like moo331.nft-owner.is. And then beauty is that's automatically assigned. So like when owner of the parent NFT changes, it doesn't require for you to pay any gas, which is kind of interesting model. And the third model is called gasless. And yeah, part of the reason why Argent stopped issuing subdomain is the fact that gas is too expensive. And that's very shame. And we've been working on another specification called EIP 3668, scale off-chain data retrieval, which is often used in combination with the wildcard example I just described. Let's say I have my token, and if you want to issue subdomain a.matoken.is for free, first, if it doesn't exist on a Ethereum smart contract, it goes to the parent, matoken.is, to say, hey, do you know anything about it? Then you can write a smart contract which get the data from something called gateway service. And instead of like previous example, it was checking on other smart contract L1, you can actually fetch the data from this gateway service, which is just like a web services and from off-chain. And I think I described, yeah, I just oversimplified all the technical detail, but the intuition is that like basically ENS itself has been there since 2017 when gas price is not so expensive. So if you used to put everything in on chain, but something like NFT people knows like NFT ownership is on chain, but all the metadata is usually off chain, such as like in OpenSea's database or some like IPFS or Arviv. So the intuition is so that like, yeah, we allow you to specify NFT metadata through this gateway service. And so by doing that, one of the example is Coinbase. Coinbase issued subdomain under the name called cb.id. So if this is example of their Chrome extension, that if you get, in my case, I had Inoue Makoto.cb.id, and if I put all their profiles are all saved into their database, but you can also reference from our website, app.ens.domains, because it's proxy through this gateway service. And I think they have a couple million usernames and the subdomains, and it's all free. So it's already out there. And also another example is when I say off-chain, it can be some random database, but it can also be other chains. So does anyone know who has Lens profile? Okay, about 30%. No, less, probably 10%. Yeah. So Lens is a kind of social network built on Polygon, and Polygon is another EVM-based chain. And so if you have Lens profile, like such as Stani.lens, it's actually proxies through this framework I mentioned. I think I didn't mention the framework name. It's called CCIP read. And so if you have Stani.lens, you can also proxy through gateway under the name of Stani.lens.xyz. That's kind of another use case to bring different name service proxy through ENS. And one thing I want to mention is like this is good and bad. That like I guess off-chain it's gasless, but at the same time, a couple of things like if you have it in the data is in a normal database, you kind of have to trust gateway as well as the data registry. And it might be okay for Coinbase because they are kind of custodial. But if you want to be more purely decentralized, you may not want to have too much kind of centralized solution. And we are working on something called L2 resolver. And the difference between off-chain resolver and the L2 resolver is off-chain resolver, you have to trust the gateway service as well as the data source. Whereas L2, I don't know how many people knows how L2 works, but one of the stuff to differentiate L2 or so-called rollup from other sidechain which has bridges is that they basically secure the security of the L2 to L1 by kind of batch committing the L2 state into L1. And this is usually not exposed to end users because people don't really use these features, but we actually kind of depend on these features so that we can write a solution to check. So when you ask data from gateway service, not only asking for data, we can get the proof from the L2. There's something called storage proof. ETH get proof is a kind of RPC call. You can call to the many chains, and you can get the proof, which includes a kind of storage proof, which is a kind of Markov tree. By doing that, you can write a L1 contract, which checks if the L2 state is in the list of the L1, the contract committed on L1. Then later, if you have that with using that and the Markov tree, you can actually check the storage position of the certain L2 on L1. By doing that, off-chain these gateway, you still have to depend on gateway service, and but one thing gateway service can do is kind of stop responding the data, but they can never manipulate the data. If they manipulate the data, that we can write a one contract to say the data is invalid. So this one, we already have a couple of prototypes, and yeah, we are trying to work on it so that it's available sometimes either this year or early next year. But currently, the L2 solution isn't really available. So if you have next project, for example, if you have a next events, and if you want to issue subdomain to all your conference users, you can create this kind of off-chain solution. And we have my colleague Greg created a demo pack to kind of show the power of kind of gasless subname creation using this repo. So if you can just fork this one, you can probably create one. And that's about it. Thank you very much.
All right. The next speaker, ChainSafe's talk has been canceled due to health problems. So we're going to take a lunch break from 1 p.m. to 2 p.m. And we'll come back at 2 p.m. with Sega. Thank you.
셋. 자, 잠깐만 이거 바꿔주세요.
All right, we're back from lunch. Next up, we have Sega, Vic. He'll be doing a talk on building blocks of DeFi derivatives, and I'll let him take it from here.
Thank you so much. Can you guys hear me okay? Yeah? Okay, clicker. Cool. Okay, so to start, I just wanted to survey the room. How familiar are people with options, derivatives, DeFi? So maybe put up your hand if you're familiar with these concepts. Okay, perfect. So this is going to be a great presentation for most of you because we'll cover a lot of the building blocks of DeFi. And I think because it's a more kind of cozy room, feel free to just like raise your hand and stop me along the way if you have any questions. We can kind of make it a more interactive presentation today. Cool. So I'm Vic. I'm one of the co-founders of Sega. We are an exotic derivatives protocol. We are operating on both Solana and on Ethereum. And I'm here today to tell you guys more about how the building blocks of DeFi came to be, the past, the present, the future, and what our involvement is with it. So excited to share. Cool. So one of our main theses is that DeFi derivatives drive institutional adoption, which is going to be critical for the growth of crypto and DeFi in large. So to begin, we'll take a look at the past. We'll dive into where we've come from and also give a quick primer on what derivatives are. So there's no mistake that DeFi is here to stay. If you guys look at the small dot on the left, that's basically where the TVL of DeFi was in 2019. So it's just at about $200 million, which if you think about the market cap of even some of the most like meme coins nowadays, it's larger than that. So DeFi was very small at the time. Fast forward to 2022, at the peak of the DeFi run, TVL was close to 77 billion. That's almost 400x in just 3 years. Seems pretty big, right? Put that dot in comparison to the overall market cap of traditional finance, and you see that we are still very, very early, still very nascent, and there's a long, long ways to go. The TradFi market cap today is more than $100 trillion, right? So it's a T, not a B, and that's where we can go. One of the common misconceptions with DeFi is that people think it's been around for a very long time, and they usually think about that timeline with respect to the blockchain timeline or kind of BTC. But in fact, like BTC's been around for quite a while now, but DeFi really only came to be in the last 5 years. And I would actually argue that really only came more prominently to light in the last 3 years. I guess like how many of you guys participated in DeFi Summer? Yeah, okay. So I think DeFi Summer is probably one of the first kind of breakouts for DeFi, and I'm sure there's gonna be more to come. So we think institutional adoption is key to mass adoption. Well, why? Part of this is looking at the growth curve of BTC and some of the kind of key events that have helped it grow along the way. So for example, in 2013, the first crypto institutional asset managers arrived on the scene and started managing BTC. Do you guys know who that might be? They're also a VC, venture capital. So it's Pantera. They're one of the largest VCs. They also happen to be one of our investors. So 2013 was also kind of a bold period for BTC. If you look at 2016 as well, 2016 was a moment where government started actually recognizing BTC as a valid currency as well. And that institutional / larger body adoption helps these crypto assets go mainstream. Okay, we'll kind of go into like a learning mode for a little bit. We'll do a little bit of DeFi derivatives 101. So to start, a derivative in its purest form is actually a solution to help manage risk. And I know that might seem a little bit confusing, but we'll kind of go into some of the examples of it. So here on the screen, I have a picture of a farmer, and you guys are probably wondering, well, what does a farmer have to do with derivatives? So agriculture is actually one of the first industries that depended or relied on derivatives. And I'll give you an example. Let's say that you are an apple farmer. So you grow apple trees and you collect apples and you sell apples for a living. And you have consumers of the apples that make apple juice. Well, why might you, the farmer, want derivatives or care about derivatives? Well, it's because your business and the yield of your apples are subject to matters outside of your control. For example, maybe there's bad weather one year and all of a sudden your yield is no longer as high or the quality of your apples have changed. But you actually want to maintain a business where the price of your apples don't fluctuate that much, and the apple juice makers who are buying it also don't want your apple prices to fluctuate too much. So you might create an agreement where you agree to sell your apples at a future date for a certain price. And that is, at the core, is essentially an options contract, which is a derivative. So if you use the past example, this contract around apples doesn't actually require the person to own any apples themselves. Derivatives are wrappers around underlying assets. So you can create derivatives around stocks, around bonds, around crypto, around apples, around oil, around whatever you want. Derivatives are ultimately based or they're derived on these different underlying assets. they're also a contract between a buyer and a seller. So you need two parties to be involved. You need someone to be selling the contract, and you need someone to be buying the contract. So in our example, right, we have the farmer who says, hey, I want you to have the buyer who says, I want to have the choice to buy your apples for $100 in a month from now. And the seller or the farmer who says, okay, well, if you want that insurance, just pay me a little bit of money right now and I'll give you that insurance for it. In DeFi, this contract happens not over pieces of paper, but it happens over the smart contract. And it's a tokenized version of that same contract that we just talked about. So if we also look at how derivative markets came to be and how that evolution has been shaped, it's actually kind of interesting because this set of flows is largely based on what we see in terms of TradFi. It's how we view capital markets to form. So on the very left, you start with asset creation, right? So for example, you have some stable coins or some value that's being accrued to a token of sorts. So you can think of, DAI or USDC or whatever you might have it. Next, once you have these tokens of value, you need a way to sell them. So you need spot markets, right? So AMMs, clouds, exchanges, ways to kind of sell these tokens that are worth money. Once you start selling them and people start owning the tokens, then naturally lending markets form. So lending markets are basically, well, I own these assets. Maybe you want to borrow my assets and do things with it at some rate. And here, and now we have lending and investment rates forming. The next two boxes are based on what we see in TradFi and what we think DeFi is naturally going to take place as well, which are futures markets and options markets. So once you have lending markets take place, naturally the next thing that you want to do is you want to apply leverage, and you want to also hedge or take speculative bets on these different underlying assets that you have. And the differences between futures market and option market are basically, it comes down to the payoff of these different options that you're buying, whether or not it's linear payoff. So in a linear sense, when markets move up, the options gains and losses move up, and non-linear meaning that you have more protection over or configurations over the options payoff. Okay, cool. Now let's take a look at how DeFi derivatives drive institutional adoption and how institutional adoption also flywheels back and helps grow DeFi. So just I guess a quick round of hands, like, are you guys familiar with what institutional adoption means? Like what these kind of institutions are? So just a super easy example is most of us in the room are probably regular DeFi retail users, right? So you have a wallet, you have some money, and you invest in tokens or coins or these different things. Well, an institutional investor is someone that invests large amounts of money on behalf of their investors. So they're probably managing hundreds of millions or billions of dollars. And so the needs of institutional investors are much more different than that of retail investors. So the four big areas that we are going to cover in terms of what their needs are benefits and utility, supply and liquidation, trust and safety, and lowering the cost of operations. So on benefits and utility, there's three things that institutional investors care about. They care about having real returns, not necessarily high yields, but real returns where the yields are coming from places they understand. So I'm sure for all of us that got wrecked by Olympus or other Ponzi-nomic launches in 2022, we know that one of the most important questions to ask for most DeFi protocols is like, where is the yield actually coming from? And institutional investors care about this a lot as well. The second asset they care about are better trading mechanisms. So this could be in liquidation, it could be in investment duration, lockups, and all of those different features as well. And the third one is a flexible view on the market. So what this actually means is that as an investor, you might say, hey, look, I want to I want to invest, and I want to take a position on the market based on the market staying flat or stable. Not necessarily that it's going to be completely bearish or completely bullish. And a more flexible view on the market is actually something that is desired by a lot of these larger institutions. Moving on to supply and liquidity. Supply and liquidity basically says, well, if I have $100 million to trade, can I even buy $100 million worth of derivatives from the market? Like who is actually providing that supply? And then similarly, if you're buying or creating the derivative, who's actually taking the other side of the position, right? Who is creating the liquidity for that options class? And what's really interesting here is that there's kind of like a chicken and egg problem where if you aren't creating derivatives, you don't have liquidity. If you don't have liquidity, you're not going to have derivatives. So how do you kind of break that puzzle piece? Well, we think that the way to do so is you have to actually first create derivatives and you have to first find demand from the people that want to take that position. Once that is established, then you can find market makers or other parties to provide liquidity for it. Once that liquidity is provided, it actually kind of flywheels back because if you're a market maker and you're hedging your positions, you're going to go back out and you're going to buy more derivatives. And so this flywheel is something that's going to happen in DeFi as more institutional money flows in. The third aspect is trust and safety. So if you're a builder here, or honestly, if you're any user, like we care about this probably as much as institutional investors do. The only difference is that institutional investors care about having additional controls on top of that. They care about knowing the transparency of the flows in DeFi, right? So where is the money being moved to? And with DeFi, that transparency is basically guaranteed on blockchain because you can just view all transactions from a wallet address. They care about counterparty risk assessment, so who is taking the opposite side of the trade. And they also care about institutional custody, right? So this means I'm investing on behalf of my investors. How do I make sure that the custody controls are in place correctly for all my operations to go smoothly? And the final piece that they care about is lowering the cost of operations. And so this, I think, is one of the coolest parts about DeFi, which is just like, if you guys consider today going to your bank and buying an options contract or buying some investment from somebody, before it reaches your hands, there's probably like dozens of individuals, humans, people who've touched contracts along the way, and every single employee at a bank essentially is a line item for cost, and it reduces your bottom line as an investor. You get less yield because of it. With crypto, with blockchain, with DeFi, you're investing through contracts, you're investing through code, and inherently code is free. What we pay for are gas fees. And so the thing to optimize for here in DeFi is basically, how do I optimize smart contracts for gas? And how do I optimize the other associated costs with managing a smart contract in such a way that we can deliver higher returns for everybody involved, right? Whether it's retail investors or institutional investors. So in this sense, creating a robust DeFi derivatives ecosystem directly leads to the creation of a larger blockchain ecosystem. It's a flywheel that works together and boosts DeFi's growth in unison. Okay, cool. So we've looked at the past. We've looked at how institutional investors will help drive the adoption. Let's take a look at where we are now and where we're headed. So from our vantage point, so Sega, so we are an exotic options protocol. We see the landscape today in terms of three large buckets. The first one are exchanges. So this is where you can go and you can buy your options. The second one is operations. So operations, you can think of it as kind of like back office. You can think of it as the back end for a lot of these different financial contracts. And then the third bucket is tokenization. So this is who is actually going and creating these tokenized smart contract representations of derivative options in the blockchain. So to start, let's talk about exchanges. So exchanges are probably one of the more mature and saturated fields out there today. I'm sure lots of you guys have probably used some of these protocols or companies, whether it's GMX or perpetuals or DOPEX, to buy your options. You can buy perpetual options, which are basically options with no expiry, or you can just go and buy regular options that have expiry. But regardless, lots of places for you to buy options today, lots of exchanges that are out there. If you look at the back office, so this is kind of operations to provide the necessary operational processes to enable DeFi. There are some companies that are doing interesting things. There are some companies that are providing for some of the problems in this space. but actually by and large, we need more work on the operations side. So if there are any builders out there looking for ideas, billion-dollar ideas, like this is an easy place to work on. Some of the existing solutions out there today, for example, you have counterparty credit analysis. So there's a company called Credora that we work with, but essentially they help DeFi protocols get an understanding for the credit worthiness of the market makers or the different partners that they're working with. You have on-chain auctions and RFQs, which are basically requests for quotations. And this is basically when you go out and you work with your counterparties, how are they providing you with bids for the different trades that you're trading? And then volatility indexes like Volmex, which provide volatility that you use for pricing these different options. What's missing today, honestly, are things like risk management, so your ISDAs, which are contractual legal paperwork that help you create binding contracts to work with your different counterparties. There are clearinghouses. We need more institutional custodial solutions and even insurance for counterparty risk. So just lots of different areas of growth on the operations side that help fuel DeFi as well. The third area that we think is also ripe for disruption and a lot of innovation is in tokenization. So tokenization means who's actually going and creating the tokenized representations of these options contracts on the blockchain. So you have today a lot of vanilla options, DOVs. So you have Ripon Finance, JonesDAO. You have exotics. So Sega, we work in the exotic space. You also have synthetic delta ones like Flux and Synthetics. But this is really a growing space that's really exciting to see what more protocols and companies are doing to bring options contracts to the blockchain itself. So a little bit more about the last category, the exotic options tokenization. So we at Sega, we're doing just that. We are creating exotic derivatives contracts on the blockchain. We're live on Solana and Ethereum. And basically the way that it works is pretty straightforward. So you, the user, so any of you guys with a wallet with USDC, you can go into our app and you can deposit USDC. And then we trade that USDC in an exotic options trading strategy. Depending on what kind of risk you're willing to take, you can basically choose between different kinds of product offerings. But as an example here, we have a product called Supercharger where your bet might be, you're betting that the price of Ethereum or BTC will not go down by more than 30% within a month. And if you're correct, you'll get 10 to 12% APY. Right? So these are the kind of bets that you're making through Sega. The really cool thing about Sega is that exotic derivatives, like I mentioned with this nonlinear payoff, we offer a more customized, flexible view on the market. And what that actually means for you, the investor, is it means downside protection. So if you buy, for example, in options, if you buy vanilla options, when prices move up, when prices move down, you're subject to losses infinitely in either direction. With exotic options, we have what's called a barrier, which means that basically if the price does not go below a certain point, you actually are not subject to any losses at all. So this kind of downside protection is something that's really interesting and unique about what exotic derivatives can offer. So some of the problems that we're tackling that we're super excited about are in a few different areas. We are super interested in tackling problems around product innovation. So obviously, especially last year, I think, it was very common to see companies just forking each other on different chains, and that was called innovation. But these days, we think that there's not enough net new innovation being brought to the space, and we're trying to work on that. There are lots of interesting areas to work on. For example, lockup periods or ways to offer users more flexibility on what kind of tokens they can stake, what kinds of offerings and views on the market that they can take. Like there's so many different and interesting aspects of innovation that we can bring to market here. The second area is we think that there today still in DeFi lacks a lack of real high yield. So if you're chasing yield today, there's a lot of really sketchy websites you might go to or a lot of projects that are unvetted. But we think that in order for DeFi to grow to the next level, you have to find real yield. You have to have your users understand where it's coming from. And so, none of the Ponzinomics, none of the inflationary token rewards, just literally, understandable yield. And the last thing is that we think it's really important to also make sure that there are good actors in the space, right? So at Sega, for example, you can talk to any of us. Like we try to make it known that if you find any of the employees, if you find any of our team members or any of the co-founders, you know who we are because we're here for the long run. Like we are here to really help move DeFi along for the long run. So hopefully users in the future have more trust in all the protocols in DeFi. There are less ruggings and there's more transparency. So some quick facts about us. Since launch, we've already traded more than $250 million in notional. We are currently the #1 ranked DeFi protocol on Solana, which is where we started with about a year ago. And we just launched on Ethereum about 6-7 weeks ago, which is super exciting as well. So yeah, I mean, if you guys have USDC, please try out our product. It's super, super easy to use, whether it's on Solana or Ethereum. And if you have any other questions, please let me know. Thank you. Thanks.
All right, next up, we have Tomas from Nethermind. He'll be doing a talk on proposers, builders, sequencers, and layer 1, layer 2, layer 3, the world of staking, and MEV, and protocol development.
Hi, everyone. Okay, great. So maybe there are some assumptions that I made, but also want to adjust them now dynamically, which is like, one was that we'll mostly have hackers here that will participate in hackathon. I think this is not necessarily true. So how many of you are hackers and participating in hackathon or builders like developing? Okay, so I thought so, that it will be less. And the other thing is, how many of you know quite well intimately the Ethereum roadmap? They understand what Ethereum is working on now, what problems they're trying to solve. And okay, and more or less, like how many of you work in Ethereum ecosystem and not, for example, Cosmos or Near? Or... All right, so what I'll do, I'll adjust it in a way to explain you a bit more about what Ethereum is doing now. I wanted to rush it a bit more, but probably I'll move a bit more slowly. Let me just guess what I need to use to move the slides. I think that this looks like so. But... All right, this one, okay. Cool. So the talk will be about a few big things in Ethereum, but many of them I think will be driving really much of the innovation or direction for many chains. Some of those things might be already available in other chains outside of Ethereum. And then you can compare actually how those different paths looks. So the few things that Nethermind works on, and Nethermind is a protocol. Oh, okay, great, I have this one. So Nethermind being practically protocol engineering company, company that does the core engineering, core development for Ethereum, building the client for Ethereum, does work on majority of the new things. So it tries to think of what will happen in Ethereum or in blockchain in maybe 1 to 3 years. So we don't really look at the maybe like 10 years from now visionary thinking, but we think of what are builders trying to solve over the next 2-3 years, where the chain is going, and how we can help the largest of the companies in the space to get there, and what products and what tooling we have to deliver. So nowadays, we mostly focus on the rollup stage, so the layer 2s, and the layer 3s that will be built on top of rollups. We work a lot on staking, which is now after the so-called Chapella upgrade in Ethereum. The staking arrives at the withdrawals, so the ability of staking and withdrawing money back from the staking in the proof of stake Ethereum is now fully activated. So this was the process of the last, depending on how you look at this, 4 to 2 years maybe. And we'll do a lot about MEV as well in collaboration mostly with Flashbots. And I'll talk a bit about this because MEV, minor extractable value, I'll explain a bit more what it is, defines much of the protocol security aspects and the direction for how protocol is dealing with it. So now, after talking in length about the title, I'll maybe introduce myself. So my name is Tomasz Stanczak, and I've been in Ethereum protocol development for the last 6 years. I've worked with a few companies, so mostly Nethermind, which I founded in 2017, but also work on the Ethereum security with Forda, working on some of the DeFi solutions with Euler. There is also Flashbots, which is MEV solutions company, like research and development company. Then there is Starknet, which is Ethereum scaling solution, Ethereum layer 2. And there is TwinStake, which is staking for institutions. So as you see, all of those companies somehow synergize into the Ethereum protocol development. So I hope that I'll be able to give you a bit of this broader look about how those things get together. Yeah, okay. So when you think about the Ethereum roadmap, the one document that many of us in the protocol engineering and Ethereum are looking at is this Vitalik's one-pager that shows this is the vision. These are the largest problems, biggest problems that we're trying to solve. We divide them into a few categories with a bit of joke, mimetic names. And we look at each of those categories and see the problems to solve, how we get there, where we are at the current stage. And I'll mention a few points here that are a bit closer to what Nethermind is working on, but also tell you a bit more about everything else. So in Ethereum and probably in many other chains, we're using the old traditional Merkle tree, or maybe not entirely traditional ones. So the Ethereum introduced this Patricia Merkle tree, some state representation that allows creation of the proofs. So very typical approach from the past, how to store the entire state of the blockchain in a way that allows for quick verification, like single root of the tree verification of the entire state correctness, or verification between all the different nodes. And well, that tree construction, the structure of the tree in Ethereum, was also causing a lot of challenges to how to optimize it. This is one of the major bottlenecks in Ethereum is the state access. State growth, the storage, mostly writes, but also reads from the state. So the databases of Ethereum, depending on whether you look on different synchronization mechanisms, may end up being with the historical formats of multi-terabytes databases, above 10 terabytes databases for archival nodes, or hundreds of gigabytes, more or less, for only the latest state. So accessing this on the disks, even the fastest I/O operations, is very often seen as a major bottleneck. Depending on the architecture of the clients that you deliver for Ethereum, this usually is more of a problem than just the EVM execution. EVM being virtual machine computation of the chain. So every time you have a block with transactions, you process transactions one by one, and there is some component of executing the operations of the bytecode, the virtual machine. And then virtual machine every now and then is asking about the questions about the state. What's the balance of the given account? What's the storage of the given account representing the balance of maybe ERC20 token, and so on and so on. So those might be basic. And the one big change in Ethereum that is coming sooner or later is the Merkle tree construction, which means we are remodeling the way the approach to the state storage and the proving of state with the approaches of the modern cryptographical solutions, actually KZG commitments. And the Merkle trees is being introduced for a few reasons. So first of all, to lead the Ethereum into the longer-term vision of like fully verifiable Ethereum in the ZK context. Like I think the Vitalik described it as snarked Ethereum. So the solutions where you can look at the block and say, oh, actually, I can quickly provide a proof that this block was executed correctly. The second thing, a bit closer to nowadays, is the space of not having a state and being able to verify the block. So bringing the witness to everything that block did. So the witness is this information about, or actually list of data points that were accessed on the tree, on the Merkle tree or the Verkle tree in this case, during the block execution. If, together with the block data, we can provide the witness, then whoever receives that block doesn't have to have the entire tree structure, just looks at that witness data and executes all the transactions and verifies them, and everything is neatly cryptographically verifiable. You can say, oh, this block is correct. But now the verifying node doesn't store any data, so you don't have that disk of a few hundred gigabytes of data. It's much cheaper to verify blocks, and you can always. The problem with the Merkle tree is that the witness in the Merkle tree can be maybe not arbitrarily large, but pretty large. So in the most pessimistic scenarios, I think it's tens of megabytes, which prevents the blocks from being shared around. And now the Verkle tree being one thing, with the verification without state, with the fully snarked Ethereum. The other part, and this one I'll say a bit more about, which is PBS, a proposer builder separation, and the aspects of MEV in this context, and also the MEV burn in this context. So about MEV burn, actually, I'll have a bit a deeper talk at Build Asia, so in a few days. So PBS in Ethereum was introduced with the with the merge in September last year. PBS means we separating two roles that normally were associated with the miners, or the miners or validators nowadays in the proof of stake. So proof of work Ethereum before the merge, before September last year, was saying that there is a miner who can, like statistically every now and then, will receive the opportunity to produce the block, depending on solving the riddle, like the famous proof of work riddle. And at that time, well, the miner is privileged in a privileged position. So miner, when they find this like solution to the riddle, they know that their block is created, and they prepare the block up front just in case they solve the riddle that has like list of transactions. Maybe they censor transactions, maybe they inject some transactions, reorder them, just to extract as much value from the chain as possible. So in the simple understanding is that for the miner to extract as much value as possible is like choose the transactions that bring me the highest transaction fees. This is the simple way as we always think about it. So what miner does to maximize the value of the block? Selects the transactions that pay the most. The truth is a bit more complex. So to maximize the extraction of the value for the miner is not only to select the highest paying transactions based on fees, but actually to look at the underlying state and DeFi protocols mostly, and see what kind of other transactions could be injected or maybe censored that will lead to transfer of value from some accounts to the miner account. And why this is possible. Imagine many of the decentralized finance protocols need mechanisms for liquidations, for example. So we say that there's a lending protocol and you provide a collateral, and if this collateral falls under some value, then we entering a danger zone. The position is not collateralized enough, and it may end up being under collateralized. So what it means, like I'm taking a loan and saying that I need to take $1 million in stablecoin, and I'm putting a collateral of, let's say, 1.5 million value of ETH. So the position is over-collateralized, and this is desired, right? So I want to have access to a stablecoin, but I'm saying I'm giving much more. putting aside the collateral in ETH, and it keeps moving. And ETH is very volatile, and I don't have really ability to act super fast, so this collateral has to be much above the 100% value. So because ETH keeps moving, maybe it will drop to just 1.1 million total value of the ETH that I collateralized. And then the protocol says, well, this is dangerous. This is no longer protecting someone who is giving you that loan in stablecoin. You need to either top up the collateral, or someone else can do that for you by executing liquidation code. So now that liquidation code very often is free for everyone, in a sense that anybody in the protocol, any user, can send a transaction invoking liquidations. And those liquidations are, well, when they happen, they are very profitable. There was a single example, I think, of during one of the big market moves. I think Justin Tran's position was that the $1 billion was under collateralized for 5 minutes, and someone could grab it, but it didn't happen, right? So it was $1 billion to take. Now, any DeFi protocol will encourage as many as possible users to be able to liquidate because they want to act fast. Like it's not in the interest of the protocol to give the loans that are under collateralized, which means that you want to encourage all the users to just quickly act and say, oh, there is some money to take, I can get some premium for the liquidation, and so on. So I'm giving this example as the only one, so that's why you go so deep into it, because now I think that if you're a miner, you're a privileged position, in a sense that when the state of the entire Ethereum changes to the situation where you can liquidate, then as a miner, you always will be sure that you can put that first transaction in a block to capture that value from liquidation. You can be the liquidator as a miner. And now the same situation happens with the proof of stake with the validators. So Ethereum now has around 600,000 validators after the merge, and the queue is growing. So we have something like 40 days entry queue for the new validators. 100,000 validators are in the queue at the moment. So more and more ETH is staked, more validators are coming to the network. And many of those validators are operated by large node operators. It can be either some like liquid staking decentralized solutions like Lido on Ethereum. So Lido says you can actually stake some ETH, but not in the direct protocol staking mechanism, but by pulling it inside the Lido smart contracts. And Lido, as a protocol, DeFi protocol, works with the node operators, professional node operators, says whenever there is 32 ETH on Ethereum is what you need to stake. So every single validator requires 32 ETH stake, which is around $60,000. So whenever 32 ETH is put into smart contract, then Lido starts a new validator with their operators. Lido now, I think, operates at around 30% of all the validators. And then there are some other large operators that work with institutional clients. Institutional clients very often come and say, oh, I would like to stake $100 million, but I don't touch the technology. I don't want to run the infrastructure. This is risky. I may be slashed. So I go to like a larger operator and say, do that for me. Now, for Ethereum, the best situation is if there are many solo stakers. If the entire network is as decentralized as possible. The same as for miners, you don't want to have 2, 3, 4 miners having all the hash power. The same for staking, you don't want to have 2, 3 large operators operating the stake on behalf of someone and possibly acting not in line with those delegators' will. So any situation on Ethereum, any design of protocol that leads to centralization of that staking into the large operators is very undesirable. So there's a long way to come back to this introduction of proposer-builder separation. So if building the block with liquidations that we mentioned is so valuable, and if finding all the possible liquidations on the chain and all the other potential DeFi mechanisms that lead to the value extraction, if it becomes complex, right? So you have to scan the entire state, you have to track maybe tens of thousands of different token pairs, different DeFi protocols, like what you've heard with Sega, or liquidations, or maybe some NFT auctions, some airdrops, and so on. Scanning that in the 12 seconds that happens between the blocks becomes very complex, which means that whoever runs a sophisticated machinery to extract has advantage over any solo staker. So I'm solo staking, and I have to create a block. I will never create a block that will be so efficient as a block generated by some traders team, like the fund, hedge fund, VC company, whatever. Whoever runs like a large cloud operations with sophisticated trading system that analyzes market data flowing in from centralized exchanges, decentralized exchanges, and so on. So as a solo staker, I say, well, that value that is extracted, that we call MEV, minor extractable value, that is coming to me because I have this privileged position of being a staker, I can never extract as much value as I would if I delegated my nodes to a large operator. So as much as I want to contribute to the Ethereum decentralization by being solo staker and running my own node at home, I will lose money by doing this instead of saying, hey, I want to stick with Lido or with some big operator, like think of any. So as a protocol engineers, we say this is a problem because it leads to, sooner or later, it leads to everyone delegating their block building to the large operators. They will not want to lose this like 2-3% yield. Some of them will stay and say, okay, I actually dedicating this node to decentralization, so I don't care about a few percent less. But many of them will think like, okay, so I want to have the best result. Why don't I even bother? I did all of this. I made all of this effort. It costs more to operate node locally, but I'm getting even less for that. I should be getting more actually. So PBS, Proposal Builder Separation, says that we can create a market where the block builders, those professional companies, professional funds, groups of traders, that very often we call searchers, the ones that search for opportunities for value extraction, they may create a market of producing the best blocks that they can find and saying whoever is the validator now, whoever is about to propose a block on the network broadcasted, can actually choose from all the blocks created and choose the best one, the one that pays the most. And those validators no longer have to even deal with block building at all. So you can think of maybe a bit more oligopolistic market of, let's say, I think nowadays it's like 30 large block builders that compete with each other for finding the most MEV opportunities. And then in the specially designed auction, they bid of how much they pay to the proposers to select their blocks. And the proposers, so the validators, say, okay, I want to participate in this auction. I connect to that market that's created on Ethereum, and I am able to access the best blocks without building them locally. So PBS was introduced at the same time as the merge was introduced. So these were two components of like the merge upgrade in September in Ethereum. And now the direction is to move even further with PBS because PBS at the moment is with a few like trust assumptions. So we introduced solutions like block builders, but we also introduced solutions like the relays, which are collecting the bids from all the different block builders and propose them to and offer them to the block proposers. Now those relays have to be trusted, that they will not try to steal the value from the builders. Because the market is like reputation based and there's a small number of relays, for now this works. This works, but not in a way that we are used to say that things work in blockchain. It doesn't work in a trustless, fully verifiable way. it works with some trust assumptions. There is probably maybe like under 10 meaningful relays that are being used by the market. So all this way to EPBS, which says enshrined protocol, enshrined proposer builder separation, which means that we propose solutions that remove the role of the relay and allow the network to connect builders directly with block proposers, with validators, without relay in between, and with just like some crypto economic protection mechanisms or like slashing, observation, attestations using all the validators looking at the network. I'm taking more time explaining everything, but that's because we've seen the result of the little survey at the beginning. I'll jump to the few other things. So one thing that I would like to underline here is the restaking with EigenLayer. So Nethermind is now partnering with EigenLayer on building tooling and solutions for restaking. And restaking, I think that it may be by many seen as like, oh, it exists in some form on other chains, I think. But let me explain that. So when we said that 32 ETH deposit on Ethereum is something that is used by validators to ensure that they can prove that they are ready to participate in network security and that they're ready to be slashed if they fail. So that 32 ETH deposit nowadays brings some yield. Ethereum pays for that security provided by validators. The same way as you think that Ethereum, that the proof of work networks pay for security to the miners by giving them block rewards, by paying transaction fees to them. The same way Ethereum nowadays in proof of stake provides some yield, some percentage reward to every single block proposer on Ethereum and to every single attester on Ethereum. So even if you're not proposing a block as one of the 600,000 validators, you participate in so-called like attesters committees and say what you're observing on the network. And all those roles are actually give you some rewards, but if you don't follow the rules of the protocol, if you fail in some like very malicious way, like for example, you sign information that is inconsistent, you sign 2 different blocks, then you're slashed. So Ethereum says, I need some deposit from you so I can quantify the level of security of how much an attacker would have to put at stake to disrupt the network. So we have the assumptions of the number of honest nodes and the assumptions like, do we say that 33% of the malicious nodes would potentially attack Ethereum? But we have to show that how much this attack costs. And with the proper deposits and the slashing mechanism, we actually can calculate the finality components of it and so on. So now, restaking says that this 32 ETH that you're depositing might be reused for the security of some other networks or some other on some other protocols. Restaking with EigenLayer says that instead of depositing 32 ETH directly on Ethereum, you can route it via a smart contract, and that smart contract can have some additional logic that says, well, not only you'll be slashed if you don't follow the Ethereum rules, but I also, as a smart contract, I can slash your deposit if you don't follow some other rules. And those rules can be, let's say, you're also supposed to sign the Oracle data that flows into the protocol. So there is some Oracle, decentralized Oracle, and you say, I would like to restake my deposit from Ethereum to show that I also dedicate my reputation, my stake, to the decentralized Oracle data. And I'll be participating in providing that data on Oracle. And if I don't follow, if I don't provide the same data as all the other decentralized Oracle participants, then I get slashed. The problem with restaking is that, well, if I overload myself too much, if I restake with many different protocols, then we have to start analyzing different numbers in the sense of like how much is at stake to protect security of Ethereum, of the network. Because if some badly designed protocol that will be potentially very hyped, like this is big chance for restaking, that people start without maybe analyzing too much, restaking with the protocols that are over-promising through the aggressive marketing campaigns. If that badly designed protocol actually decides to slash everything, like all 32 ETH, then imagine that 50% of the network restakes with a protocol like this and everyone gets slashed because of some error bug in the project. All of this is burned. And now 50% of the network of the validators realize that they have no more ETH at stake, so they don't care about whether they protect Ethereum or not. So the Ethereum security falls a lot. I'll skip the other components of this one. We don't have much more time. I will mention a bit about shared sequencers. So this is specifically my area of interest in the last 2-3 months. Shared sequencers are mostly used in the context of the rollups, but also probably extended into like multiple domains, multiple layers. Shared sequencers say that, well, the sequencer is someone who chooses transactions for construction of a block. Very often people say, well, sequencer, proposer, or maybe even block builder. This is being used sometimes interchangeably, and sometimes there are very strict definition given. Specifically for Korean market, I think that one not mentioned here would be the Radius network. So definitely look it up and check how Radius network is offering the shared sequencing and separation of those concerns. Well, I'm running out of time. I gave you much more details on particular items. I invite you to maybe look at the Middle Asia talk, where I'll focus a bit more in-depth analysis. But for today, I'll skip some of those. Yeah. So thank you so much. Invite you to contact me for any more discussion during the event. I'll be happy to answer any of those, especially if you came here to learn about more details of everything that we talked about, then I'll be happy to see you during the event and after. Thank you.
All right, next up we have Polygon. They'll be doing a talk on Polygon ID is building the marketplace of trusted credentials for Web3.
Sorry. Okay. Hello, everybody. My name is Antoni. I am one of the co-founders of the Polygon CKVM and Polygon ID. And yes, today we will speak about how we are building a marketplace of trusted credentials for Web3. Okay. Why this topic is really hot right now is because we have seen, we fixed the problem of scalability. This was one of our main problems for the last 2 years in the Web3 world. And now we are facing the problem of identity, especially with the artificial intelligence and all these bots that are appearing. and where it's very difficult to see if we are speaking with a human or with a machine. At the same time, when we discuss this with governments for the last year, we have been speaking with a lot of different governments around the world. They always tell you that, okay, blockchain is very easy to trace, okay? And then how you ensure your privacy, this is one of the challenges that we have and that are avoiding the mass adoption in the real world. A very clear example could be also in gaming or DeFi, how you can assess which is your age, how you can ensure that you are older than 18 years, or in Europe at the same time we are facing a lot of regulations named MiCA, but basically related with QAC and anti-money laundering. Also, we were in discussions with UK, or Polygon recently, we did an exercise with the Bank of Singapore, with the Singapore dollar, and this question on AML was always one of the topics when we were discussing with them. And this brings us to this old meme, but that today is very actual, let's say, or is very realistic, no? That at the beginning of the internet age, the question is, okay, who is there? And at the end, there was this joke about a dog. But what we are facing today with the rise of the artificial intelligence is that sometimes you think that you are speaking with a human and maybe you are speaking with a machine, that it could be extremely realistic and provide always the right answers, or answers that are very difficult to differentiate from a real human, no? And curiously, when we address this problem directly to ChatGPT, he said, as you can see here, that one of the ways to verify the authenticity of the content is to include the use of blockchain as a security parameter, no? Which was something a little bit curious, that for themselves, one way to ensure the authenticity of something is to use our own technology. And for this reason, we think that we cannot postpone anymore this debate on the digital identity. And with this, I want to bring you a very tangible example. This was happening 2 weeks ago. In Twitter, a verified account suddenly said that there was this attack on the Pentagon. This was fake. It was AI generated, but it's true that the US stock market felt very strongly. There was a huge dip, and hundreds of millions of dollars were lost, okay? And I am speaking about a verified account, not about a random guy saying a very strange thing, no? Then this is showing us that the challenge is already here. I mean, it's not that we are speaking about sci-fi in 20 years. It's something that we need to address as soon as possible. With this, what we want to ensure is that, okay, the users need to be humans, of course. They need to be unique. They need to be compliant. I mean, there are different rules that need to be followed. At the same time, reputation is something critical. I will elaborate on that later. And they should be trustworthy. Otherwise, fake people or random people can start to troll about news and create the wrong content, no? Then, with all these factors, what we can achieve is we will be protected against civil attacks, okay? Especially nowadays, where we have hundreds of bots or thousands of millions of bots. We need this kind of protection. Otherwise, the dApps could be swamped by some of these attacks. In this sense, we are believers on digital reputation. Okay, we think that in the future, the community will give to some users according to how, and in this time of so many fake news, also during presidential elections or governments, we think that people who is able to provide the best content will be the one more followed and the one which opinion will be more respected. Also, what we are facing is that in different exchange markets, or when we speak with centralized or decentralized exchanges, all this question about to be compliant, they are under a huge pressure, and we are living that in the US, but also in Europe is there, and in some exchanges in Asia is also arriving. And with verifiable credentials is something that we can fix in the future. Then in our Web3 world, DAOs are very important. And the fact that also recently there was an attack on Aragon, for example, where the DAO was extracting treasury because it was a coordinated attack, also with bots involved. And in this sense, one person, one vote is something that we should keep in mind. And as I said at the beginning, also with this fake news, the content authenticity and the proof of provenance will be something critical. We need to ensure that the data is the right one. And with all of these factors, we think that we can achieve this mass adoption and to bring more transactions to Web3. With this in mind, what we decided at Polygon ID is to create a marketplace of trusted credentials for Web3. And the reason is all what I have explained before, no? That this will allow to the different partners to use this marketplace as a reliable source, because there will be some features embedded in these verifiable credentials that will ensure that we are speaking about reputable proofs. And in this sense is why we say that we are on a mission, okay? The idea is to create these liquidity credentials in the Ethereum ecosystem, and where we will connect issuers with verifiers in the centralized service in different apps, okay? In this sense, what we are speaking already right now is with different providers that are providing these credentials to Polygon ID or to the Web3 world. In this sense, it's true that now we have started all our exercise for obvious reasons in Polygon, but we are agnostic and we are open to other platforms or other chains. We think that this should be something very global. Otherwise, in this fragmented world, it can die very quickly. Our technical guys are working very hard to create the SDKs and the APIs in order that you can all developers can be integrated in Polygon ID and data, and the credentials can be stored on or off chain depending on the value and the use case. And for the final users, of course, we are being as much compatible as we can with different wallets. As you can imagine, it's more easy now at the beginning to merge with the smaller ones, and it's more complicated to go for the bigger ones, but we are speaking with them because as a user, you need to have your credentials in your hand in a mobile or in a web version. And I think this is the more important slide from the whole presentation, okay? Because at the end, what we are trying to do is to create an ecosystem. I mean, this is not an effort that we can do alone. And here, as these are all the companies that are already merging with us, that are already part of our ecosystem. As you can see here, we are trying to bring credential issuers, also different wallets, as I said, and system integrators, as could be Kaleido, for example. And this is only the beginning. I mean, this what we are doing in the last weeks. We are speaking with also big incumbents that are starting to be interested in this concept. And the idea is to bring as many players as possible in order to make this ecosystem growth. This is not one thing that Polygon ID will do alone. We need as many players as possible being part of the concept. Yes, then what I can really encourage you is to go to our GitHub. Here you have the QR code. and here you can start to experiment, or you can start to play. Okay, in this sense, you can issue your own credentials, or you can become an issuer of a third party. Here is where when we were speaking about reputation, is something that you can explore on this front. You can verify different credentials from your partner, from other companies, from other dApps. In this sense, also a lot of these verifications are happening or are in smart contracts in an on-chain way. And at the same time, you can download your SDK mobile wallet, or as a developer, you can use the different JavaScript libraries to adapt it to your web or your browser. Yes, then my claim today, and my ask is if you are ready to build these trusted relationships today. Okay, this is something that we are looking forward. This is why we are here also in Seoul the next days. Then if you have any question, reach out to us, reach out to me. We have a huge team trying to create this whole ecosystem and this cooperation. Okay, this is part of the ethos of Web3. And let's make something together. I mean, as we said, we already fixed the zkVM, or the scalability problem with the zkVM that is already live in Polygon, and other companies are almost there, which sounds really exciting. And we want to do something similar with the identity space. Then if you have any question, please let me know, and otherwise reach out to me outside of this hall. Thanks.
All right, we're going to take a short 10-minute break before the next speaker starts.
Ah, this way. Yeah, yeah. Right. That's good. Perfect.
All right, we are back. Next up, we have Gateway FM. They'll be doing a talk on the ZK app chain thesis.
Yep. Hi, my name is Igor, yeah, and I'm here to talk about private rollups and app chains in general. So first, a little bit about myself. So have a technical background, engineering background. I've been in the non-blockchain industry for quite a while, was building fintech, browsers, security, and stuff like this. Then in 2017, joined Status, which is a messenger slash a wallet, mobile wallet. Then for a while, I've been an Ethereum core dev. Likewise, Tomasz from Nethermind, like working on Aragon team, one more node. And I've been doing a little bit of research. If you've been on the Tomasz presentation, he mentioned witnesses. So I was the one who measured them and brought this news. And then right now, I'm CTO and co-founder at Gateway FM, and we are, as a company, basically we're one of the core devs of the Gnosis chain. We're a little bit helping with, like again, node architecture on the Polygon zkVM side. And in general, we provide quite a bit of infrastructure that we try to diversify from both the client perspective, client diversity perspective, and also on the data center diversity. So we work with independent data centers around the globe to make sure that like no cloud providers can capture too many of the RPCs and validator nodes. And one of the, you see that we are used by quite a few clients already. And one of the important things that we also like a Polygon Supernet implementation platform, and Polygon Supernet is essentially an app chain platform, and this is what's to some extent inspired this presentation. So at first I wanted to talk a little bit about just in general what the app chains are, then how can we use private rollups, ZK rollups as app chains, and a little bit of a roadmap should we at Gateway, how we see the future of this. So yeah, basically we start with the basic, what is an app chain? And it's basically, if you can imagine that you have some kind of application or maybe a couple of applications that use this blockchain and you don't maybe even see it. It can be publicly available or not. And it's you can think about it as basically a mechanism that's very useful when blockchain meets real world, right? Because when you are within the blockchain space, when you are doing DeFi or purely digital connections and stuff like this, you are fine with blockchain limitations. But then when you work, let's say, try to connect it to fintech or traditional finance, there might be some compliance, security, privacy, or maybe some performance limitations that you just cannot, like maybe the current solutions that's kind of designed to be one size fits all, like a public rollups or public layer ones or something like this, they might not fit. Maybe you want some UX and interesting gaming mechanics or tokenomics within your blockchain that is not available on the on any of the rollups, or maybe too expensive to do on some kind of a smart contract level. So, and you can think about this as also a scalability version of the blockchain. Like way back when we had this Serenity project that was renamed to ETH 2.0, right? When we had the idea that we will scale Ethereum in a way that we have multiple shards, so the shards will be different. Some will be executing smart contracts with EVM, some will have some WASM smart contracts, we'll have beacon chain to kind of manage them all. That's one way of like scaling the base layer. But then it was kind of rebuilt in terms of, oh, let's instead of trying to scale the base layer, we will do layers on top of that, like layers 2 rollups, maybe layers 3 later on. And then we see there that these purple applications, they are land on these layers neatly. And with app chain thesis, basically, is that you have one-ish like application to one-ish chain. And in this case, I show this is like more of a Ethereum specific when we use private rollups. They all are merged by layer 1 Ethereum here. But there might be like, let's say, Gnosis also have this notion of Ethereum verse when you have multiple chains that all run on the beacon consensus, so then you can kind of breach things and treat them as app chains within the same ecosystem. That's another kind of way that's not here. Okay, then the next slide, basically, if you look at modern app chains, again, you have the Cosmos ecosystem or Polkadot or Avalanche that were built forever ago with app chains in mind. We have some ideas of how to do this on Ethereum as well. I'll focus mostly on Ethereum, and I think having the base layer to be like Ethereum or something that's decentralized and neutral is super important here, and I'll talk a little bit in depth later about it. And then if we switch to the rollups themselves, so we want app chains and we want to use rollups as app chains. So what is a rollup? Essentially, it's two things, right? To be called a rollup, basically you need to have some kind of a blockchain that runs, you can call it on top of, let's say, Ethereum, and it has two connections to Ethereum. One is data availability connection. It basically means that in case rollup goes offline, you can still recover the whole state of this rollup using only layer 1, only Ethereum in this case. And the second is some kind of a proof on chain there. And then, of course, this setup is a bit expensive to run, often, especially the data availability that usually has scalable cost. The more transactions you have on layer 2, the more expensive it is to provide data availability to it. So there is also a notion of validiums when you just have on-chain proofs, but you don't have data availability on layer 1. Sometimes you might use off-chain availability committee for that, but still it's like a validium. So it's a cheaper version, but then you have a trust assumption that either this off-chain availability committee or the layer 2 rollup operator does not go dark. And the same way you can do basically layers 3 as well, when you can have a layer 2 as a rollup or as a validium, and then have like layer 3 as a rollup on the top of a rollup, which is also one more thing how you do basically the scalability solution. And then we have two types of rollups, right? We have optimistic rollups and ZK rollups, and one critical difference between those two is that in optimistic rollup, the proof that you have to provide on chain is the proof that something went wrong, right? So by default, everything is okay. We're not checking anything, and we're trusting the system, right? But then, if let's say multiple people are running optimistic rollup nodes, that might be like, oh, this was an invalid transaction that was made. And then you need to kind of prove the system to challenge these things on chain. And this approach supposed to be done by the optimistic rollups. And then we have kind of a ZK rollups where the proof is, it's actually the proof of correctness. The rollup has to publish the correctness proof every now and then on layer 1 to see that all transactions, all state transitions, all EVM execution, everything was done correctly. And I roughly divided it in like 3 generations. So first we had a very simplistic ZK rollups like StarkX or ZK SyncLite, right? They were operational specific. You maybe could transfer money through it, but you cannot do any generic code execution. Then we have, again, I roughly call it generation 2, StarkNet and ZK Sync era, because it's kind of, they have EVM compatibility to some extent. StarkNet has a transpiler that, again, Nethermind team is working on, for instance, which can take your Solidity code, transpile to Cairo, and then it compiles to the bytecode of StarkNet rollup, right? Then on ZK Sync error, it's a little bit shorter. The process is shorter. It takes Solidity code, and using like LLVM or something, it's compiled towards some kind of a bytecode that's then ZK Sync is using. And then we have ZKVM from Polygon, which is basically a bytecode compatible ZK machine when your Solidity code is compiled to the same bytecode as on Ethereum, and then it's executed in the virtual machine that looks like and feels like Ethereum virtual machine with like a couple of caveats, but they're very minor. Okay, then basically if you send a transaction to a ZK rollup, or ZK VM, let's say, then at first it's just getting sent and then sequenced, means sequencer includes it into layer 2, and then to basically save money on the gas fees, they're getting batched to put them together. Because if you put every transaction for data availability on layer 1, basically you will have the fees of layer 1-ish. Maybe a little bit less of them, but if you batch them, you might save on the fees. So before it's sent to a layer 1 for availability, you kind of need to trust at this point that the rollup will not like go out of service or will not do anything because it's not yet protected by layer 1. But then as soon as it's sent to the data availability, you can at least again recover the state if you want. And then after that, usually quite a beefy server generates a proof for this batch of transactions and sends this to L1 smart contract. And this L1 smart contract actually checks the validity of this proof. And the proof is basically, it validates all the state transitions, all the application of these transactions. And as soon as proof is sent to L1 and validated there, you can basically, at this point, you can think that it actually has security guarantees of the base layer of Ethereum. Before that, you still have some trust assumptions of a rollup. Here I want to switch 2 slides. I don't think we will, yeah. So the data availability is one more thing. It's like there are 2 approaches to that. Basically, one is when you send inputs of transactions like Polygon ZKVM. Basically, it sends transactions to be executed in batches in layer 1. And then the other approach is, if I understand ZK Sync and Starknet is doing this, is that they store on chain already the state diff, what the difference is, what changed in the blockchain after the transaction was applied. Like each has its own kind of a pros and cons approach. So yeah, that's another 2 things. So basically, if we combine all of this together, we're looking into using this ZKVM or some kind of rollup technology that's has the security and data availability of layer 1 and use it as an app chain. And there's like a couple of the current already tools that are kind of based on the rollup. You see like there are super chains, there is Saga, there is like tools like Caldera that takes the optimism stack and stuff like this and set up a rollup for this. So, and now the point of contention with the app chains was always kind of a centralization. And to kind of, I'm giving it, if we're using the right technology, then like I think we can give it a little bit of a, I would say it's a little bit less requirements of decentralization on the app chains. And the reason for that is that I say that decentralization is not the kind of a, it's a good thing, but it's not a goal in even of itself, but the properties of decentralization is what we actually care about. And there are 2 properties that I want to show here, and the one property is liveness. Basically, if your system is properly decentralized, that means that there is no single entity that can shut it down, right? So in case, like, let's say if Ethereum is really well decentralized, no matter like if, let's say even Lido goes completely dark, Ethereum will still be working, right? Or let's say if Infura goes completely dark, Ethereum will still be working. So there is no single entity that controls it. And the second is that it's basically user agency, which is also very important. And user agency means that regardless of what a single or like couple of entities want really, users still can participate in the network, and users still can, if needs to be, like exit this network. So these properties are like what's important and they are actually achieved through decentralization in terms of base layer. But since we are building app chains as rollups on top of this base layer, then we can kind of have something of this, something similar for that without having to completely decentralize things. So first, of course, there is still a property of liveness that's very, very useful. But since rollups usually or should publish the data availability onto the base layer like Ethereum, you can, like, even if rollup goes dark, you can still just launch it yourself and have all the state, the same state as it would have been in the rollup that was running by the original team. Of course, there is like a caveat that you need to be able to run these things. So it means that it should be open source at least, and it should be able to run. There shouldn't be any hidden components to this. And also, of course, the smart contracts for this, they should be well audited, and it should be like proven that they actually publish what they claim they publish, right? And the second is that with this computational proofs, and usually the notion of either forced exits or forced transactions or something like this, it means that you as a user, again, for an extra fee, but you can force, regardless of what the sequencer or people who run this centralized sequencer think about, like you participating in the network or you exiting the network, you can still force them into like executing a certain amount of transactions. So in the KVM, like in Polygon, yes, there is a notion of like a forced transaction. So it could be like any transaction that sequencer has to include, regardless of if it wants to censor it, it just cannot censor it. Or if the sequencer itself will not include it, then you can run a sequencer that includes it, basically. And then there are also some kind of a caveats to this. And one caveat is, of course, that the state is not changed yet until at least you have data availability transaction sent to the Ethereum, and until the proof is, ideally, the proof has come to Ethereum as well, it was verified, right? You cannot trust fully the state in this case. And the second is, of course, that's what I talked a little bit earlier, is that it actually brings quite a lot of requirements on the underlying layer 1. I mean, if your underlying layer 1 is run by the same entity as layer 2, only one entity, then you don't have anywhere to exit. Like you basically, you will collude one way or another. So about non-finality, and that's a little bit of a thing that it wasn't really formally described before, I think, proof of stake consensus, but you all seen like in your wallets or something that, oh, this transaction has this many confirmations on top of this, maybe some operations are executed when it has 12, some executed when it's 24. But like when it was proof of work or in Bitcoin days or legacy proof of work Ethereum, basically you didn't have this notion, okay, this transaction is final and will not be reverted. It just, with each next block on top of this, is harder and harder to revert it, but theoretically not impossible, right? At certain length, it becomes purely a theoretical exercise, of course. But then with Beacon Chain, there is a notion of finality. For instance, there is a thing called Casper friendly finality gadget in Ethereum consensus. When, for instance, your blocks are grouped into epochs, and when there are at least 2/3 of validators online, it kind of marks this epoch as final, and that means that it's guaranteed by the protocol that the transactions in this epoch will not go anywhere. And I would argue that ZK rollup also have this notion of finality, and this notion is when the proof is proven on the layer 1, right? After that, you kind of have these guarantees that well, I mean, if you're going really, really deep, then when the proof is checked by layer one and it's final, like because layer one also can rework in theory, which is very unlikely. But then you also have this, you can kind of transaction, okay, this transaction in theory, if somebody who runs sequencer really wants, can be reworked away. But then as soon as the proof reached layer one, there is nothing to do for the ones who run the sequencer. So that's why I also want to have this notion of finality in the rollups, in the key rollups, and it's important. And then again, base layer neutrality. Basically, you exit into the base layer, you exit into Ethereum or maybe to Gnosis or something like this. And base layer for this, it actually needs to give you this property of agency and liveness. And since it's a base layer right now, we don't have any better tools to give it to user than good decentralization. So, and I would say that this kind of a property of, again, neutrality, if you want to call it, when single entity cannot like censor you or something like this, it can a little bit bubble up, again, with a certain caveats, with less strict guarantees, upwards if you're using, let's say, zkAVM rollup on top of zkAVM rollup on top of Ethereum, and Ethereum is well decentralized, then with certain caveats, you can think that layer 3 is also can bring some of the security and not decentralization, but liveness and agency to the user. So to put it all together, if we take zk rollups and start building up chains on this and base it out of credibly neutral and decentralized networks like Ethereum or Gnosis chain, for instance, you can get a lot of the properties of the app chains that you want, including the custom tokenomics, performance characteristic, just prices and stuff like this, or compliance, for instance, benefits for certain regulated industries, while still giving these properties of agency and liveness through data availability and computational zero knowledge proofs, for instance. So that's kind of the thesis that I did. And then to bring it into more action, then I wanted to say that there's of course, caveats are everywhere. The one thing that I forgot about, there is still, like if you're doing DeFi, for instance, especially on the app chain approach, you will end up with liquidity pools being quite fragmented. So right now, the biggest liquidity pools are on Ethereum. Some of them, of course, are on shared rollups like Arbitrum, Optimism, and stuff like this. But then there's one thing that's if you're doing DeFi on app chains, that's one of the trouble. And there, like things like shared sequencers approach could potentially help, or some bridges like LX2LY from Polygon zkAVM, or this Hashi that's system that Gnosis is working on. Then, of course, purely constructing these zero knowledge proofs is expensive, means hardware expensive. You need to rent a pretty beefy server at this moment. Of course, the teams are working really hard to take this cost down, but still, like, you need to run quite a bit of a server. And if for each app chain you have to provide this server, it bumps the cost up quite a bit. So for this, I would say that first we can work on the efficiency of the proofs themselves, algorithmically, or maybe using more specialized hardware or something like this. Or we can use also shared prover across multiple app chains so we don't have to provision it many, many times. And then there are base layer fees, of course, because both data availability and proofs are sent to the layer 1. You will have to pay gas fees on the layer 1. So, and these fees are, again, for data availability, they are kind of they dependent on the size of the amount of transactions you want to send there or something like this. For the proofs, they are basically, they're more or less constant, but still, let's say state diff approach wins here because it's cheaper, because you can bundle a lot of transactions. Let's say if we had 5,000 transactions between only like me and Tomasz, for instance, there will be a very short state diff for 1,000 transactions there, right? Which might work in the cases, again, when you have super, super popular single application, when everything is changing in one smart contract. Or we also can work like basically more efficient in terms of maybe some recursive proofs to make the proof themselves smaller and smaller, to be able to include multiple proofs in a single aggregated proofs and stuff like this. So now to the practicalities. So one of the things that is happening is that, like on the Polygon supernets, basically the future supernets, there is more and more moving towards that they will be private rollups on top of Ethereum, for instance. So that's kind of the typical supernet high-level architecture. And now it's, instead of having their own validators, their own kind of a stake and stuff like this, it's more using layer 1 RPC to be able to synchronize it. And we at Gateway want to also take it like a little bit a step further. Again, it's a little bit a long-term vision, is when we want to allow users to create their own, not only like a rollup, but the whole like environment with just a couple of clicks, with like both the block explorers, I don't know, identity providers, wallets, like multi-sigs and stuff like this. And basically to provision it with a couple of clicks and maybe like a couple of minutes after this waiting time. So yeah, so that's basically it. That's what I wanted to say. So feel free to reach out to me either here if you have any questions or want to just discuss this thing. Here is like our official Twitter, my Twitter. On the public Gateway FM, you can find a lot of, again, public RPC. If you want to like use it in your project, like they don't even require registration. And here's my Telegram handle. So yeah, I think that's it for now.
All right, next up is Biconomy. They'll be doing a talk on how to start building on account abstraction today with the Biconomy SDK.
It's not your personal.
That's my phone.
Oh, really? May I add? Can you connect it or something?
Yeah.
No? Stable, so that's why I pressed it. That's okay. That's one more slideshow.
I'm gonna be.
Hey everyone, thank you for coming to my talk. We're going to be talking about how to get started building with I'm short, so yeah. Cool. So it's how to get started building with account abstraction today using the Biconomy SDK. So hey, I'm Rahat. I'm head of developer relations at Biconomy. Formerly, I was a front-end engineer for a few years. Did some Solidity dev as well. Former founder, like tinkered and built with a few different things. Also a former hip hop artist. I've retired, so I will not be rapping on stage today. You can just a couple places you can follow me. I look like one of these two things online, so these are me. But today we're going to be talking about the current UX of Web3. How many developers in the house? Okay. As a developer, have you ever accidentally committed private keys, an API key, or something to GitHub? No? Yeah, it's happened, right? It happens to everyone. And if it happens with one of your Web3 projects, you might have private keys associated to a wallet that you put up on GitHub, and then someone comes and drains all your funds, and you get wrecked. So this is not a great, UX, especially for developers or really anyone, because if we have to keep track of these private keys that are associated with our accounts, these seed phrases and everything, it's a lot of complexity, a lot of ways for people to kind of drain, all of our funds from these accounts. And this leads to a complicated Web3 UX that happens whenever you're, trying to get onboarded onto a dApp, right? If you think about it, if you're brand new to Web3, the first thing you have to do is create a wallet. After you create a wallet, you then go to an exchange. You get some money onto that exchange. You send money from that exchange to your wallet, and then you can use a dApp. There are many, many friction points before you can actually use a product. If you're at this hackathon and you're building a product for users to actually, use, Web3 is very hard for that because there are multiple friction points before they can ever use your product, and that's a pretty bad thing. And the last thing is gas fees. Paying gas kind of sucks, especially if you're, on an L1, wherever. But we have different scaling solutions for that. You've spoken to a couple people just now who are talking in that direction. But we can take a lot of these experiences and make it so that people don't have to deal with them so much. How can we actually fix this? How can we improve the user experience in Web3? In comes account abstraction. So account abstraction is maybe something you folks have heard about for a while. A couple months ago, what happened was an ERC 4337 was launched onto the Ethereum mainnet. And we're going to be breaking down a little bit what that means, how that helps us, and how that actually can help your Web3 UX. So just a gist, just like a TLDR, what exactly is this thing called account abstraction? It's really the ability to add arbitrary logic to the process of validating a transaction. So take any transaction, it's the transaction itself, there's this, with 4337, there's no actual protocol level changes. What we're really doing is just looking at a transaction, adding additional logic around it, and doing whatever we want with it. So this additional logic and the way of tracking it, these things are called user operations or user ops. So user ops are going to contain all of the information that you will eventually need to execute a transaction on the blockchain, but they will have additional points to them that allow you to do more things. I mentioned an entry point contract earlier. There's an entry point contract that would be deployed on every chain, and this entry point contract essentially handles everything that goes through this account abstraction flow. So we're going to go through that brief overview of that architecture in a second, but what we really do is what we're trying to do is achieve better UX through smart accounts or wallets that are deployed with smart contracts. So rather than having a wallet that is secured by the ECDSA, it is secured by code. And once you have a wallet that is secured by code, you can add your additional arbitrary logic on top of that. So the main things you want to ask yourself in this is what types of authentication do you want to add to your transaction? What do you want to do before a transaction actually takes place? And this is where AA can come in and help you out. So here's a brief overview. The little green box is what you can imagine to be a smart contract wallet. It can be owned by an externally owned account, which is a regular wallet that you might be used to right now. It can be owned by, and one of the use cases we'll show you is like social logins being owned by like an email address or anything like that. There's multiple ways that you can actually own this account, but this account, again, is run by code, right? So that arbitrary logic just depends on like your imagination, pretty much. So this wallet is going to handle sending all of your user ops to an alternative mempool. It's just where a whole bunch of user ops exist. In this alternative mempool, you'll have a service called a bundler. Bundler just is a service, can be written in Rust, TypeScript, whatever, that is going to be looking through the mempool, looking at these user ops, and sending them to the entry point contract. So the entry point contract now has functions that allow you to handle all of these user operations, right? And from the entry point contract, there's a few other interactions that can happen. You can, it validates the user ops coming from the actual smart contract wallet, but it can also interact with what's called a paymaster. Paymasters can do pretty cool things, one of which is sponsoring gas for a user. Another one is allowing a user to pay for gas in any token other than the native token that they want. So now you see like other contracts coming in, being able to add additional logic, additional kind of like use cases for you in this sense. So account abstraction is something that takes some time to really wrap your head around. I've done a few like threads on Twitter and things like that. So if you want to like go through and do like a whiteboarding kind of approach on account abstraction, you can take a look at a couple of the things that are linked through here. I'll leave that open just for a sec. Cool. Now, I explained a whole bunch of things about contracts and things that are deployed, but you probably don't want to code all that yourself, right? You want to get started building with these stuff as quickly and as easily as possible. So today we're going to be learning a little bit about the Biconomy SDK, and we're going to look at two different demos to do so. So we'll start with the first one. How many people have like swapped a coin on Uniswap before? Okay, a few people. So, or just swapped any coin on any exchange. Let's go through this really quickly. Refresh. All right. So this is a demo that I built, which is just a miniature version of Uniswap. I have this connect to Web3 button, which is just like a traditional, almost like wallet sign-in. All right. Now, I can connect with MetaMask, Wallet Connect, whatever, but today I'm just going to be connecting with Google. So I'm connecting with my Google account. What's happening under the hood is this package is utilizing Web3 auth to create a Ethereum address for us, but we're going to be taking that and actually using that as the owner of a smart contract account that is being deployed in the background. And that is all being done through the Biconomy SDK. So that's loading here, but now this address that I have here is a smart contract wallet. And you'll see I have a little bit of crypto on here. These are some of my assets. And this is the first kind of like layer of things, right? As a non-Web3 native person, I can come in here. I can use my Google account to generate an Ethereum address for myself. It's completely bypassing, some of the onboarding that it normally takes to get into Web3. Next thing I want to do, I have some funds in here, but as someone who is not native to Web3, I might need to get some funds onto my account. We have complete fiat onboarding within the dApp, so I can come in here, grab whatever I need. This specific dApp is on the Polygon network. Somewhere in here. There it is. And it's using USDC for everything, so I would buy some USDC. Previous to this, I just sent myself some USDC from another wallet. I've got 8 here. But the other thing you'll notice here is that there is 0 Matic on this account. So generally, when you're on the Polygon blockchain, you have to pay for gas in Matic. That is their native token. There is no Matic on this. So that's another thing to keep in mind. So now I'm going to execute a swap. This is on mainnet. So this is going to be an actual mainnet transaction. So on Polygon mainnet, I'm just going to swap 1 USDC for wrapped Ether. Hit the swap button. Swapping is happening in the background. Now, generally when you swap, If you're swapping for the first time, you have to approve a certain amount of tokens to be able to do the swap. What's happening here is that I'm only approving the exact amount of tokens that needs to be swapped, which is 1, and at the same time doing the swap. So I'm taking 2 transactions, bundling them together, A, to save on gas, and B, so that someone who is not crypto native doesn't have to think about approving and then swapping. It is just done for them in the background, and there's a safety layer because they're only approving the specific amount of tokens that you want to actually swap, right? So this is my actual transaction happening right now, Polygon scan, and it was a success. So we've gone through, you'll see that this interacted with the entry point contract on Polygon mainnet through our Bioeconomy bundler. And I took $1 in USD coin and swapped it for wrapped Ether. So this is a full LiveNet real transaction that just happened. Cool. So how do we actually do some of that? Take a look at a little bit of code. This is some of the code that is actually powering this transaction completely. So a lot of it is just using some of our SDKs, right? So the first kind of thing you can look at is the Web3 Auth SDK that we have, which just is powered by Web3 Auth under the hood. There's not a lot you have to do. I have a login function here, and all of this is just boilerplate code that you can get directly from our docs, where I'm just initializing the SDK. I am whitelisting the specific URL, so this is in production, so I'm just making sure I whitelist the production URL, and basically just get set up there. There are styles that CSS files that you were given that I put into like my main app folder. This is an XJS React app, and those styles are what's making that login widget actually look the way it is. You can completely customize that. You can gut that. You can rebrand that to whatever you need it to be. But out of the box, if you want to just get quickly started, you have that sign-in widget ready for you to go. The next thing to kind of look at here is going to be setting up the actual smart account. So like I said, the account that I showed you is an account that is governed by code. So that is done for you in this session here. Again, just utilizing our smart account module from the Bioeconomy SDK. You're just specifying which chain you want to deploy on. You get an API key from our dashboard, which I'll show you in a second. And at this point, you have the option of either deploying the person's account for them right away. Again, if you set up a paymaster and gas tank on our dashboard, that is completely free to them. Or on their first transaction, that deployment would just be added to their actual first transaction. The cool thing about this type of account is it's called a counterfactual account, meaning that you already have an address for that specific account before it's even deployed, right? So before it's deployed, you have an address, you can start sending funds to it, and then once it gets deployed through their first transaction, you're good to go. So now we've set up the smart account, we have everything there. We have just like a logout function. And from here, the main other thing is the actual swap. Sorry, my computer seems to be a little slow. Okay. So again, so the actual swap happens like once you create this smart account, it essentially, if you've ever used a package like Ethers.js or WAGMI or anything like that, the API for using that is very, very similar. Slight changes, of course, but you would initialize and get your API, pass a provider to your package. Are you good? Okay, something's going on. Sorry, I'm not sure. What's up? Am I like, are you also like my terrible desktop? Don't know what happened. Okay. And I'm apparently like recording this. All right, I'm not sure what happened there. We'll pretend that my desktop was never shown live. So, okay, now I can move through things. Let's see, swap component, where did I put it in here? Okay, yeah. Here's where I'm actually handling the swap. So for handling the swap, I'm using a pool address for wrapped Ether to USDC, which is available from Uniswap. It looks like my computer restarted somehow. I don't know what, sorry. But the tokens that I'm just using for this example are USDC and ETH. So these are the addresses for those. And what's really cool here is, I'm just using the Ethers.js package to get a connection to the contract. And for whenever I need to directly interact and make transactions, I make sure that I have an instance of the smart account. So the smart account that was created in the previous component, I've just passed that down here. So these are the actual transactions. So I just populate transaction. First is this approve that I mentioned. So the approve is just going to take the swap router address and the exact amount that is going to be approved. This is my first transaction, just that the address that it's going to, as well as the data for the transaction. These are the parameters for the actual swap. This is just from the Uniswap documentation. And what happens here is like I take my smart account and it has a method called send transaction batch, which takes an object that contains an array of different transactions. So that first transaction for approving and that next transaction for actually doing the swap. So it's really, you just build out an array with the transactions that you want to execute and you pass it to this function. And you now have the ability to execute several transactions in one go. So this is a very basic example, approving and swapping. But think of like other use cases in DeFi. If you want to swap, add liquidity, stake, whatever you want to do, you can do all that in one click. And this allows us to like actually bring users who are not familiar with Web3 and DeFi concepts into the space. We want to, at some point, we just have to like make it as easy as possible for folks to come in and actually use the products that we're building. When you're building a product, if you're not optimizing for your user's experience, that's a problem. If you're only going to be kind of like marketing to Web3 natives, you're not going to have a lot of users. Our space is still very, very small. So this is just a one way of like onboarding more users into Web3. Cool. So let's take a look at the actual dashboard. So this is what the Biconomy dashboard looks like. I'm going to sign in with GitHub. There's multiple options for signing in. And these are my paymasters. Essentially, this is like a paymaster as a service. You come in here, you create a paymaster. You don't have to worry about the contracts. We kind of like take care of everything for you. If you wanted to create a new paymaster, you click here. You name it. And you choose the network. These are some of the different networks that we support. So I did one on Polygon. I'm not going to completely register. Okay, I guess I registered. But I'm not going to do the full thing here. But the last part is really like just setting up a gas tank. When you set up your gas tank, you just connect your wallet, add some funds, and these are the funds that you use to actually go ahead and sponsor the gas for your users. Coming very soon, we're going to have a token paymaster, so that rather than just paying for the gas for the user, just think about that example I showed you. Instead of you paying the gas for the user, they pay completely in USDC. So it's not having to worry about the native token, being able to conceptualize how much they're spending in gas, and doing it all through one token. So I'm going to go to this mainnet demo contract that I have. And here I can actually add and authorize different contracts that can be sponsored. So first is that swap router. So the swap router, I made sure that any functions that are specifically associated to swapping are authorized to be sponsored. So as soon as you add a smart contract address here, the ABI is going to automatically populate as long as this is verified. Or you can just add in your own ABI and then authorize each of the different write methods. And I did the same thing for link, wrapped Ether, and USDC. I haven't actually implemented the link yet, but if we look at the USDC contract, the approved method is approved for actually sending out USDC. And the transfer, I'm going to be implementing a transfer so you can actually transfer out the funds from the account into another wallet. And yeah, that's kind of how you can get started today. Using the Bioconomy SDK, getting started with account abstraction. I do have some resources that you can use to actually get started. This was just the demo of what I just showed you, just in case my demo failed live. It did not fail. Wonderful. Only my computer failed. But here is a starter kit that you can use to get started building with all of this. So this starter kit has 3 repos attached to it. One is a basic NFT example of minting a gasless NFT. It shows you kind of how to actually set that up. One is an even more basic example of a counter smart contract where you just increment a count and make that completely gasless, add social logins and everything around that. That is also the example in our quick start guide on the documentation, so you can compare that and see how to get started there. And the last example is just a Next.js authentication example. It gives you all the different configurations that you need so you can quickly get started in building on top of these. And if you're excited to build, we would love to know what you do build. You can tag us at Bioconomy, myself at Rahat Codes on Twitter. And thank you. I'll be around if you have questions, if you want to meet up and chat about anything. Thank you.
Next up, we have GNO Land. They'll be doing a talk on the evolution of smart contracts, a journey into GNO Land.
Yeah. It's okay.
Should I go? Yeah. Hi, everyone. Today we'll speak to you about a new smart contracting language named Golang, which is not in Ethereum, not in the EVM world, but aims to be an alternative that will connect to Ethereum in the near future. So to get started, I will speak about the history of smart contract starting 30 years ago, when it was just a concept, so before the blockchains, a concept not as the piece of code you name a contract, but as a protocol that will embed the source code, the execution, the proof of execution, so that you can remove the middleman. So 30 years ago, we were using cryptography to try to remove middlemen, but it actually was not yet used in production, in blockchains, in a trustless system. But it was already designed to support financial transactions, but not only. At the origin, it was also something for social coordinations, democracy, governance, and other features where you want to have trust in what you execute. There was a nice analogy with the vending machine. So when you just give money, you get your can of Coke or whatever, and you don't need a middleman. Basically, smart contracts were designed to be like vending machine, but for any kind of source code. So 2009, Bitcoin happens, and you don't have real smart contract yet. You don't have a Turing-complete machine, but the concept of programmable money becomes something. The concept of smart contract is woken up. So 20 years later, we are thinking about, okay, now we can make something with trustless, with proofs, but we can remove completely the middleman from A to Z. So it's not yet Turing complete. You can basically just have programmable money for simple instructions like multi-signature. And it gave an idea to what you know well, to Ethereum, VM. 2015, we have a Turing complete machine, and now it's possible to create decentralized applications, and it has a huge adoption with more than 10 million contracts published just last year on Ethereum. So here you have something made with a new bytecode, a new language, unique for this blockchain ecosystem. 2019, we start having many new initiatives to try to compete with Solidity and EVM, both on limitation, like the stack limit or complexity, etc., but also to try to bring new developers to the smart contracting world. So we don't need anymore to learn a new language to start creating contracts. You can come from the Rust ecosystem, from Golang ecosystem or whatever, and start building contracts. So today we have a lead, which is Rust, but technically you can run a huge amount of languages. So a quick recap. 30 years ago, we have an idea. 10 years ago, we have real smart contracts with Turing complete VMs, and the adoption is huge. So it was quicker, very quick. And about GNO, GNOland is a new ecosystem where we try to push the limits on all the current limitations and try to design a new era for smart contracts. It starts with a new language and a new VM based on an existing language, Golang. So it's a famous language to build blockchains, Web2 applications, and many kind of applications, actually. It has its own L1 blockchain, GNOland, which is not the only one that will support GNOlang and GNOVM, but it's the first one and will have special features. It's built on Tendermint 2, which is a new version of the famous proof-of-stake protocol that powers many blockchains, including Polygon and all the Cosmos blockchains. It has a new consensus mechanism. So all of you know proof-of-stake with Ethereum v2, but we are trying to create a new one, proof of contributions, which is basically a proof of stake without the financial incentive part. The whole goal of the ecosystem, because the vision is to make something that will stay for years, we aim for extreme simplicity, security with transparency, accountability, auditability, and we want to scale the smart contracts to make a system where you don't have any virtual limits. So today I will speak about something which relates to Solidity, more like an alternative where we try to push it to the next level. So first, we create a new language based on Go. Why Go? Go is an established language with millions of developers around the world. And we think it's a very good language in terms of features, in terms of simplicity, philosophy. So you have something simple to read, simple to write, simple to maintain. You have very good security by default. Maybe you can find these languages with more security, but the one in Go is clearly a good threshold with simplicity and security. And a thing that is actually an opposite direction with other languages is that we want something garbage collected. People from Rust and other modern languages will want something without garbage collection because it will give them a lot of room for optimization. We want extreme simplicity, meaning that we took the trade-off to limit the amount of optimization you can do. So we wanted a language where you just focus on the logic and not on the optimization. So that's why we chose something which can be counterintuitive, the garbage collection. And a last very good feature about Go is how it handles objects. It's not like Solidity. It's another method using embedding and composability. The good thing about this is that for complex graph of inheritance, you can prevent conflict more easily than for Solidity or other languages. And now, why do we want to create a new language, and why don't we just use Go on blockchains? So Go is not designed for blockchains. It is designed for backends, local applications, web applications. We created a language dedicated for blockchains, so it has built-in determinism, which is not the case for Go. It's interpreted, which is not the case for Go and other languages like Solidity, because we like having an understanding of what the code will do, what will be the execution frame, what will do your import, what is the data structure. So basically, instead of taking a dependency like OpenZeppelin at the build time, you will upload OpenZeppelin, and then you will upload a contract depending on the uploaded version of OpenZeppelin. Meaning that at the end, we will have an amount of statistics not only for the contract you call, but also for the dependencies. The VM is intuitive, which is not very important for contract developer, but in terms of something you want to maintain over time, you want to extend, it's important to have a VM, a language that you can easily understand, debug, and extend. It has auto-persistency, which I will show you makes the life a lot easier and justify why GNU is actually a lot easier than Golang with WASM. And it has automaticalization, which fixes basically two things. One, to create more rich types, and two, to have Merkle tree available by default for the whole chain. So why it's an intuitive VM? If you look at Solidity, EVM, etc., you have a first language, Solidity, just designed for this use case, which is transformed into a custom bytecode, the EVM bytecode, which is also very unique for this usage. And at the end, you will have an implementation, a VM implementation in another language. With GNU, we wanted to have a unique language for the contract. We wanted to have the same language to run the implementation. And in the middle, we wanted something simpler than bytecode, and we chose the default AST. So the AST is a human-readable version of the language. You have it for any other languages, and it opens doors to have better debuggability, extension, and competition against your own implementation. In terms of auto-persistency, that's where GNU will surpass a lot all the WASM implementation with other languages. So when you develop as a developer, you have two representations of your data. You have the one in memory, the one you use for your logic with the conditions, the loops, etc. And you have the state. Most of the programs, including in the Web2 ecosystem, will depend that you load your state, then you do your logic again over the memory, and at the end, you store the state, you save the store. The idea here is to not ask the developer to load a store, save a store, make translation between bytes and with decoders, encoders, etc., but to just focus on the logic. Meaning that we have something similar to Solidity. In Solidity, you have something equivalent. You don't have a store load, store save. You don't have decoding, encoding. Where on GNU, you won't have the obfuscation that you have with Solidity. You won't run into bytecode. You won't have a contract named 0x something, but you have something equivalent. Now look at what we can have with WASM. So this is a snippet, because there is a lot more code if you want to create a Rust WASM smart contract. But basically, you have a lot of boilerplate code around, so you have something to load your state, to save your state, to route your messages. So it's clearly more complicated than Solidity and GNU, even if Rust is a language that exists and have its own community. If you look at Go and WASM, it's very not common yet. Clearly, I think Rust is way better than Go for WASM contracts, but that's the same. So you have something equivalent to the GNU contract, except that you don't have a single line. You have many lines to load the store, to translate the binary version of your store, and do the same for storing at the end. Something we have in the Cosmos ecosystem is dApp chains. And app chains are basically blockchains that you can extend with code, with modules, that will do the same as smart contract, except they are not published on the chain. They are built in and create new verbs to your blockchain. And even here, to create a simple increment counter, you need to have 4 files and many code to load. You need to manage the determinism, etc. So even here, without WASM, with standard Go, it's harder to create contracts. Now, if you look at just simple Go, so this snippet is not Web3, it's Web2. It's just to load a file, transform the result of the file into an integer, increment the integer, and store it. Even here, you have more code. So at the end, you don't need to care about the storage, and it also works with more complex types. In the example here, the node is a complex structure that have reference to pointer to itself, to the left node, to the right node. It's a tree, and it will be stored without any problem. And it won't just be stored without problem, because it will be stored in an optimized way. You will have an automatic difference between the start and the end of your transaction, understanding the structure, and also Merkleize in a way so that you can verify what's on the chain without looking at the whole chain. So you have automatic Merkle trees for everything, which allows you to create a browser version of your a browser client that will understand the chain without having to synchronize everything. Another very big difference between GNU and WASM or even Solidity is about how we manage imports. On Solidity, for instance, you will import another contract, and you will have calls that will be limited to primitive types. You will need to pass strings, integers, and receive the same. In GNU, the goal was to make something as in Web2. When you import something, you can use the full structures, and if the structure is not a string and integer, but something with multiple levels of data, it will work very effectively and without effort. So just to give you another example, it's not expensive to call another contract from another contract. You just load the contract once, and then you can make thousands of calls. It will be basically costless. As for Solidity, we can have interfaces. So here is the equivalent of the ERC 721. You create your interface. As soon as you implement the interface, another contract can receive data from your contract, even if your contract was created after. So we have something equivalent and as easy as in Solidity. So at the end, by creating GNU, we are creating a new language, but which is already known, and we don't have, like for WASM with Rust, with Go or in other language, we don't have to relearn how to manage the state, how to manage the routing of your contract, how to, I don't know, to manage determinism. You just focus on writing simple Go code, which can even be simpler than Web2 Go code. And a good thing about this, about the automatic persistency, automatic Merkleization, is that at the end you can have very more complex structures, allowing to bypass the goal of making the best DeFi applications. One of the first contracts we did was a forum, so something with comments, with a lot of text, with authors, with ENS system equivalent, and the contract was very short, very powerful, and this is an example of how we can do more complex contracts when the data structure is automatic, simple, optimized by default. So you have contracts which are very simple to read, very simple to maintain, but also that can go far further. Sorry. Another part about GNU is, since you have interpreted code, it's not possible to obfuscate your code. It's not possible to hide your code with bytecode. You don't have to decompile everything. You have the source of everything you read. Since the blockchain also understands all the interpreted code, if you have a call to a single contract which imports other contracts, the blockchain will understand this too. Meaning that with some history, if you create a new contract depending on famous libraries, for instance, an OpenZeppelin equivalent, you can review a simple new code which has imports which are already audited, already trusted. So it can also ease the discovery. I don't know for developers if you like to browse GitHub and discover projects and look at the authors the organization, the amount of commits, the dependencies, etc. But basically, we want to offer this. We want to offer an experience when you can easily discover what you will execute, discover what library you want to use for your own smart contracts. So at the end, you can browse, you can discover, audit, use, and fork everything which is on GNU. From day one, the goal of GNU was to not only solve simple smart contracts, but also scalable smart contracts. So in the Cosmos and IBC ecosystem, we have IBC to make inter-blockchain communication. We have ICS, which is a new feature to basically increase the security and make better Satoshi score of decentralization of your chains. And the goal with GNU is to connect to existing IBC and ICS implementations, but also to push forward. So at the end, this thing about making simple contracts that can import other contracts will be pushed to other chains. So at the end, you can expect maybe to have a chain dedicated to an ENS alternative, and you can, on your chain B, depend on and import and use the other chain and keep structures and understanding and type safety across multiple chains. So we can help solving the scalable smart contract by having maybe an internet of blockchains, which will all be specialized, maybe some for storage or memory or speed or whatever. And then some things that I talked about at the beginning. We want to create proof of contribution, so a new consensus mechanism. It's not only a way to reward people in addition to proof of stake, it's the thing that will replace proof of stake. The goal is to have a voting power and decentralization of the chain, not based on the amount of money, not something that you can trick by coming with a huge amount of money, but instead to focus on expertise and values. So by contributing to the project, to the ecosystem, you earn points, which is slow, which is harder to trick and to take over a chain. The goal is to create a voting power based on the amount of contributions, meaning that if you can vote, if you can participate, you understand the project, you involve multiple hours of your time to understand the philosophy, how it works, the backend, and everything. So we want to make something protected from financial abuses, and that will be complementary to other chains in the ecosystem, thanks to protocol like IBC, ICS. So in the future, you can expect to see GNU that works with proof of contribution connected to other chains with proof of stake, and have the best of both worlds, where you can be secured by something which is resistant to financial attacks. And for you, if you want to check out, to try to convert your Solidity contract to GNU, to give a try, you can visit the GitHub project, the website, gnu.land, and help us create Game of Realms. Game of Realms is an online competition we have at the moment, where the goal is to bootstrap the community of contributors. So by participating, you are helping the project to happen, and you are entering the DAO of contributors that will own the chain and the genesis of the mainnet. So by participating now, you can help earn rewards. We give some atom prices and become actors in the genesis. And the best thing to do is to contribute. So if you're a good developer, you can contribute to the smart contract to create standard libraries, famous libraries, or to even improve the engine itself, which is also in Go. Thank you very much. I will be there if you have questions, if you want a small demo, discuss, whatever. Thank you.
We're going to take a short 15-minute break while the other speaker gets here. So we'll start soon. right, our next speaker is here. We have Suji from Mass Network. He'll be doing a talk on entering the network states, the revolution and future of decentralized social. And I'll let him take it from here.
Hello. So hope everyone is not so hungry. I'll be very fast and just so you guys can go to dinner after that. Okay, so my topic is the network state, entering the network state and the revolution and future of the social network. So as you know, this thing is being written in 1996, the year I was born. The year I was born is not important, right? And but this masterpiece is very important. This thing is called Independence, a Declaration of Independence of Cyberspace, written by John Perry-Barrow, co-founder of EFF, Electronic Frontier Foundation, which is one of the pioneering NGO back in the 90s, suing a lot of cases against the United States government. And obviously they win a lot of cases. That's why we have the freedom of the, well, some kind of freedom of the internet and some kind of freedom of cryptography today. So he wrote in 1996 in Switzerland, Davos, February, the government of industrialized world, your weary giants of flesh and steel, I came from cyberspace, the new home of mind. You have no sovereignty where we gather. So that's basically one of the, I don't know, like one of the founding masterpiece of our industry, even before the modern cryptography was born. But later, as I mentioned, EFF became one of the foundational player fought against the DoD and Department of Defense and Department of Commerce, and win some fundamental war. That's the past. So what is the future? And what is the takeaway from 1996, where the year I was born, and obviously that's been around almost 30 years now. So takeaway from Barrow's speech, from Barrow's declaration in 1996 is we have one goal, very easy to understand, is to create some kind of independence thing. It could be a state, it could be an organization, it could be something, some kind of independence thing over the cyberspace, superseding the nation state. Well, that's quite clear, the goal. It's been 27 years. And the battle is also quite clear, that we are in this great civil war that we are battling. And this is quote from Abraham Lincoln, that testing whether any of us can long survive. And the question is not the fight. The question is not the war. It's how we pick and fight the war, right? And obviously we already win some war. We already win some war over the underlying blockchain, on the financial freedom. But we are also losing some war. We're losing some war over the social network, over the censorship. So how to fight the war and how to pick our ally? That's the battle, right? And the other thing is our comrade, our role model. And soon after this declaration, there's something called cypherpunk mail list that the first generation cypherpunk gathered, including the Satoshi Nakamoto. Maybe he's a man, a female, doesn't matter, angel, whatever, a piece, AI. He's also part of this cypherpunk mail list, and including other great pioneers like Edward Snowden, Aaron Swartz, and Julia Assange. They're all in the list. And that's some of our previous role model, and that's the path, right? And then eventually, again, as mentioned, the goal is very clear, and the mission is also very clear. This is another quote from Lincoln, that we should have let the governance of the people, by the people, for people, never purge from the cyberspace. So yeah, so what we are having right now, I will just go back to my own company and my own stuff later on, but what we have right now, if we really look into the human history, from a very interesting perspective, we're kind of like in a digital feudalism. The feudalism, which refers close to the medieval feudalism, that you have kings, you have kingdoms, you have knights, you have all these things. So the digital feudalism that we are having a very interesting phenomenon, that every big giants today, they're just kind of like the East India Company. So East India Company is European superpower these days, try to colonize China and India and all these other places. It's formed as a company, right? It's formed as a company. They have stocks, and start asking you to even trade some of their stocks in the London Exchange. So they have stocks, pretty cool, just like tokens, and they form as a private company, but they're licensed by the sometimes European superpower to systematically colonize a place they just discovered. You can call it new continent, or you can call it whatever, doesn't matter. So today, those big tech companies are pretty much like the East Indian companies. So like Tencent is the Chinese East Indian company. By the way, there's many East Indian company back in the days. The important ones are the British ones, right? But like, for example, right now we have the Chinese East Indian company for cyberspace, Tencent or Alibaba, and the American East Indian company for cyberspace, maybe Facebook or I don't know, Twitter. Twitter maybe not the case, but that's the very interesting historical parallel we're going to see. And we are at the very interesting stage. People call it Web 3.0, right? But I think that's the kind of like the phase third of the colonization, and that's the time we start to get independence. So the first stage, Web 1.0, is we just start to discover this new amazing new continent, right? Just like the Europeans start to discover, oh, there's a place called America, pretty cool, let's go. And that's the first stage, right? And it's like, all are these cool people gonna go to cyberspace, right? Usually not really those people for colonization, just say, oh, this is a cool place, let's go. And they don't really treat it well in the old place. Well, that's Web 1.0, in my opinion. And Web 2.0 is they start to fight each other. They start to form this kind of like different colonized state, right? Say, oh, this is the colonized state from, well, the Great British Empire. This is the colonized state from the King Louis from France. Well, which is what they having right now, that they frame each other as spy. Say, hey, dude, Tito is a spy because you're from the King Louis, right? And we're from the another king, so we're not spy. So that's what's happening right now in the Web 2.0. It's the second stage of colonization, honestly. And the third stage, we use this term Web 3.0, but honestly, I think it's just like, if you ever watch the Star Wars, is these Jedi start to kind of like have rebellion. So Web 3.0 is, I think, well, rebellion start to gather together, and they start to gather and form their own community. And this is my own background. Before I jump full-time in crypto, I'm more an activist or hacktivist. So people use technology and engineer knowledge to do activist stuff. So I wrote this thing called anti-96 license back in 2018, 2019, and directly shit Jack Ma and also get his like backfire in China. And this thing get covered by all this international media, Reuters, Wall Street Journal, New York Times. If you're interested, search it. But this is a war, a battle case in the traditional world, not in the cyberspace. But I think this thing can also happen in the cyberspace. How? So everyone probably heard of the kind of like cliche word network state from Balazs, right? And he's been mentioning this thing over a year now. So yeah, what he's trying to say, or what he's and his like previous pioneers trying to say is like, oh, we will have kind of like a new power structure, that in this new power structure, we will not have like intervene from other nation state, really cool. And we can have all these technologies able to build this thing. So what we have right now, Bitcoin sounds like a piece of land, sounds like a continent, or Ethereum layer 1 sounds like a continent that is hard to destroy. You cannot destroy a continent. You probably can just let people move away from this continent, but you can never destroy it. It's just being there. So then we have some kind of financial freedom. We kind of like have people trade on top of this, the new continent and colonized state. People are going to trade there. So that's why we have ICOs and DeFi's, right? That people start to think, oh, we maybe want to trade freely on this new continent. Then it's kind of stuck there. Since 2020, 2021, people have many other interesting things, GameFi, NFT, Web3 social, SocialFi, all these like buzzword. But it seems like we lost the we lost this like grand plan. What's the great plan? How can we use this technology to achieve the final goal, the independence of the cyberspace, and how this contribute to the governance of the people, for the people, by the people, right? There's no master plan. So I happen to have some kind of pieces for this master plan. So which is why I start this thing. I will introduce later on. And I got this idea firstly from Julia Assange, that our task is to secure self-determination, where we can all hold back the upcoming dystopia, where we cannot. And if all those fail to accelerate, it's self-destructive. So yeah, okay. How can we do this? Okay, finish the network state 101. How can we do this? I really need a plan. So we are here, as I mentioned, we are kind of like have the currency stage, and we have our like DeFi thing, very cool. We have our like ICO thing, everyone can kind of launch their own token, very cool. Yeah, what's the needed thing for a country? If we want to start a country, what is other like 1 or 2, 3 pieces we need to go? So I think it's the relationship between the product force and production relationships. By the way, if you learn some like left wing, whatever, socialist ideology, this is quite common terminology. Product force and production relations. So AI are now the big topic, right? Everyone switched to AI, every VC switched to AI, they kind of abandon Web3. So AI is obviously bring you more efficiency, right? You can work better with the AI. Everyone with one open AI, $20 per month, you can make it work better. So that's definitely the product force, but never change the production relations. So the relation between you and the worker and the other laborers contribute to the data source was never changed when you use just a pure AI product. So that's why decentralization of Web3 is needed. And as I mentioned, we are kind of in this weird stage. We have all this financial infra, I think, almost ready. And then what's next? And why is the NFT, become quite booming in last 2 years? Why is there GameFi? And why are these important and an important contributor to the future of our state, future of our network state? So I will use like a historical example because again, people are hard to imagine the future if they don't know the history. So I was using the historical comparison of the new continent, and European company colonized American, and then they got some independence. People want to do independence. So now I'm gonna use another history story. Probably you guys know better in Asia. That's from my hometown, from China. So question, who's the first Chinese guy to do ICO? Okay, a hint, his last name is Sun, and obviously not Justin Sun. So yeah, Dr. Sun Yat-sen, well, that's my opinion, not from the historical book, but Dr. Sun Yat-sen did a lot of like token sale or coin sale back in 1985. That was the Qing Dynasty, which you have like old lady have no idea what he's doing. It become the empress of the China. And Dr. Sun, he's very smart. He discovered the powerful use case of the first one of the first and longest history DAO, Chinatown. Well, Chinatown is very very DAO. Okay, you got someone everywhere. They just gather together, and you have no idea what they're doing. They just gather together and eat some Chinese food. And you go to every Chinatown, you're gonna find an old guy, like a kung fu master. These guys like the treasury managers. They don't use banks. They don't use banks until very lately. They just trust their old guy, and they have like this treasury management. I don't know how they do it. Very cool. It's like a DAO. And you have their sub-DAO, right? Like YGG, you have the YGG Japan, IndyGG. Well, I mean, that's definitely copy-paste from Chinatown, because Chinatown have all these like different kind of, I don't know idea how they manage to communicate. By the way, that's the time few people can afford the Telegram, the real Telegram. Few people can afford that, so I have no idea how they able to connect. Maybe they're from the same ancestor 200 years ago. So yeah, Dr. Sun discovered this thing called Chinatown, very cool. And he discovered another thing is called printing, also very cool. In our modern world, it's called minting. So he discovered that the modern printer can print money, print paper as money, very cool. And he just signed it, use his hand. Well, not use the cryptography wallet, but what he discovered is like, oh, I found a DAO and it's everywhere, and people generally hate this like, fucking old emperor, whatever, and they generally have the treasury management and they generally have my money. And I also discovered new technology that can print money as long as I sign it. So he just print a lot of the Chinese Revolution coin since 1895 to 1911. That's around 16 years. He did 10 to 11 ICOs while he just bought a new printer everywhere, big ones, and paper ink. Chinese Revolution coin come out, and he just sell the coins to fund the revolution. And well, that's the ICO and the DeFi, okay? Very easy. By the way, all these different coins can convert to each other. So if you buy the old Dr. Sen's #1 revolution coin and he failed the first revolution, you can convert into the #2 one, just like DeFi. You know, pool 1, pool 2, whatever. You can mint another coin based on his like a new revolutions. And he also discovered NFT. Wow, that is also a very interesting thing. That thing is called Telegram. Not app we use every day, but the technology at that time was just invented and got some mass adoption. That we can use the Telegram to send over information, and then we can have like local people print other things for us. It sounds like NFT. Well, and we can monetize them. We can sell them much more cheaper because like tokens are again. For those OGs and whales, not easy to buy. NFT, oh yeah, I mean, just for breakfast money. As long as you don't buy those cyber monkeys, just buy those cheap ones, everyone can afford it. So yeah, he discovered this like Minpao, which is one of the first revolution newspaper in the Chinese history. I believe actually in the one of the first revolution newspaper in the whole Asian history. That he said, oh yeah, this new technology is really cool. Those like Chinatown OG can buy our coin, but if those who don't afford it, we can just buy our NFT. And also you can learn something from it. It's a pass, right? If you hold this like new revolution newspaper and working, people will know, wow, you're from the cool party, okay? You're from the cool revolution party, you're different. And the girls will fall loving with you, because you're obviously different than the other China guy. So yeah, great. So that's the thing he also invented. NFT. So that's also contribute massively to the creation of a new country. So a little bit introduction of our own business. So as you may know, I'm the founder of Mass Network. We've been doing social network from 2017. That's a little bit 6 years now. We've been behind this like Mass Network token, Mass Network protocol. We've been everywhere, and then we also do other stuff, right? Because again, people need to have easy access to this kind of like newspaper thing. So we have an all-in-one app called Firefly. There's a QR code here. And we have a DID protocol called Next.ID. You can just search Next.ID. So the DID is also very easy. So when you subscribe a newspaper in 1895, basically you have a DID, okay? Because they know your address, okay? Somehow your address. And they know your relationship. So you're like the second uncle of the student in the town, so they know who you are. It's like ENS, right? Okay, from which chain you have a name, and this name have the .eth or .bnb, doesn't matter. So that's pretty much the first DID, and we are kind of learning this trend. So yeah, we want to do the aggregator of DIDs. That's also one of the business. So again, we think it's also not enough, right? Because when you really study the Chinese Revolution or the American Revolution, you're going to find that, okay, all these guys there to do revolution, they're kind of rich, okay? They're from the family or from whatever, they're kind of rich, have no idea. Or they got investors, right? I don't know, and I think like, it's very important if someone try to do some revolution stuff and the VC is just like too scary, and they just like, I love AI, and they just run away. So I think, yeah, okay, we want to help them, and that's why we have like our own venture arm. We call it Bonefile Union. The name Bonefile is from the movie and comic V for Vendetta. Remember 5th of November? That's the Bonefile Festival from that was not the British Empire, from the England, right? Recommend to watch the movie again. Really good one. So we have the Mass Network, the protocol, and a lot of products over there. And we have our Bonefile Union to systematically fund the cyberspace revolution. So without a systematic funding, I believe all these revolution will not happen in the past 200 years. And we are lucky that we live here today, that it's a world that with better technology and a better human right, that a lot of people found this revolution 200 years ago. And this is what I believe, and also this is a quote from quote from John. He passed away a few years ago, again, the co-founder of EFF. I believe we'll create a civilization of mind in cyberspace, made it be more humane and fair than the world your governments have made before. So this is my contact, Sujian, and follow me on Twitter. Feel free to ask any questions. So I think we are pretty much in this very interesting point that we may witness, in a few decades, we may witness this birth of the new nation. Thank you.
All right, everyone, we are done for today. We look forward to seeing you tomorrow at 1 o'clock for Starkware. Thanks.